Good morning everyone. This is the first class of CEM 612 CAD lab for those students who could not come to the college for giving their lab. So as such, let me first have a brief introduction of the corresponding software which we'll be using. As such, we have the basic STAAD Pro software, which is actually a structural analysis and design software, which is used for analyzing of structures as well as designing of structures. So in this STAAD Pro V8, as you see here, is a corresponding version that was commonly used. The latest version is a STAAD Pro Connect version, which is a bit more have a different type of graphical user interface compared to the old one. So as such, I shall be looking on to the study of STAAD Pro, the basic outline of what the STAAD Pro software is. As such, let me first click the STAAD Pro software as such. So here you can see the basic interface that comes up when you click the STAAD Pro software. So as such, you can see the different project tasks here, the recent files that is open here. Okay, and if you are going to the Connect version, okay, if I go into the Connect version, okay, this is the Connect version. So Connect version has an interface somewhat like this. Okay, here as such, here open, new, archive, share help, etc. there, and then the recent files will be displayed here. You can open a new file by clicking the new file here. Okay, the interface is slightly different from that of the STAAD Pro V8. Okay, this is STAAD Pro Connect edition. Okay, which is almost like a STAAD Pro Connect edition is the latest update by the Bentley. Bentley is the company which releases the STAAD Pro software. Bentley has got a large number of softwares besides STAAD Pro for analyzing. It has got MX Roads. You must have heard about MX Roads, MicroStation, RAM Concept, a large number of softwares, STAAD Foundation, etc. STAAD Foundation. There are a large number of softwares which the Bentley releases, and the most commonly used for structural analysis and design is the STAAD Pro. Okay, so this corresponding is the STAAD Pro Connect edition. So I shall be more predominantly concentrating on the STAAD Pro V8i, the older version of this. Okay, since the graphical interface is much more easier in the STAAD Pro V8i, but finally I shall come to the Connect edition. Okay, just explain you where the different commands are. The interface is slightly different, rest all the basic engine of how the STAAD Pro works is the same. So let me first start with a new project. You can see here the new project here. Okay, so a corresponding window will open here. For the time being, I think I will make my mouse a bit bigger so that you can see my screen. Just give me a sec. I'll use a black pointer. So I had made my mouse slightly bigger so that you may be able to follow my corresponding cursor. Okay, so I close this out. Fine. So this is a corresponding basic window, a new model dialog box that opens when I click the new project here. So there are a number of types of structures as such that comes out here. One is space, plane, floor, and truss. Space is actually a three-dimensional space in which all the degrees of freedom will be available to you. Plane is if you restrict the corresponding rotations or displacements or forces in one plane, we can apply for plane. Then floor as such, it is meant for floor structures, and finally truss members in which the degree of freedom will be restricted to only the axial forces. So it is very important to identify which type of model you are adopting, and selecting the appropriate option is very important. Now as you know, we are doing the questions as such. Okay, so let me show you the first question. So this is the first question, which you must have seen it. It is to determine the corresponding reflection and support reactions due to a trapezoidal varying load. So this is actually a plane structure, means it is the entire beam is in one plane. So for me, it is sufficient in order to choose a plane in this corresponding figure. Now here you give the corresponding file name. Okay, for the time being, I am given a structure 1, and here you have the option of selecting the location where you want to save the file. It's slightly old fashioned, so you'll have to go to the top here. Okay, select the appropriate drive. You can select the appropriate drive and save where you want it. It is usually by default saved in the Pro V8i SS6 in STAAD plugins. So you can let it remain there if you want it as such. So here you can see a plane structure is bound by global XY coordinate system with loads in the same plane. When I click each of these, the corresponding description of that model or corresponding description of that structure as such will be shown here. So for time being, I'm taking as plane. Now here you have the length units as well as force units. So you can select the length unit as meters and the force unit as kilonewton here. Okay, so I click the next button. So as such, I have already created an earlier file here, structure 1, you can see here. So it's asking me whether I want to overwrite it. So if you are overwriting it, the older thing will go off. So for the time being, I am overwriting it. I say for the time being, yes. Okay. And then another window box will open. Where do you want to go? So a number of options are available. You can start adding beams, adding plates, adding solids. Okay, depending upon what type of model you are modeling, you can directly add beam, plates, or solids. Or there is an option called Open Structure Wizard. It is actually a library of standard standard structures. Okay, it's a library. We'll discuss that later. Then you have a STAAD editor. This option also we'll discuss later. Finally, we start with, I can either start with add beam or I can start with edit job information. So I usually start with edit job information because job information is very important when you start any project. So as such, when I click the finish button, so my corresponding interface of STAAD Pro will be like this. Okay, this is slightly different from that of the Connect version. If you go to the Connect version here, okay, this is how the Connect version is there. So if you want to open a new file, you come here, you click new. Okay, and here this corresponding you'll have to give the structure name, then you'll have to give the corresponding location where you want to save it. But as time being, I'm just saving it here itself. Okay, and then you want to choose what type of model you are doing it. So we are usually using analytical models. So in for our purposes, now in our exercise we'll be using analytical models. So you click analytical. Okay, and the units, they'll ask whether English or metric. English is the foot-pound system, metric is the SI units. So I click SI units, and as I told you, STAAD Connect as such is what we called a version in which you have an option for a cloud-based system. That means multiple people can work on the same corresponding file. Okay, multiple people can work on the same corresponding file. So in case you are looking for a cloud-based server where multiple people can work, you will have to give the title here as well as a model seed file here. Then the job information. Okay, this is the job information. In the older version, you can see here the setup. When I click, already this interface is there. So in this interface, since I clicked the job information, okay, here the job information such comes here. So let me just tell you the basic outline of this interface. you have the different menus here. Okay, and I click each of these menus here, you have the different options that are available, and then you have got tools at the top. Okay, tools for the, in these corresponding area you have the entire most of the tools that are commonly being used. Not all tools are available here. The most commonly used tools are shown here. Okay, all the tools will be available within these menus. Okay, if you click each of these menus, the entire tools are available in the STAAD Pro will be shown here. The most commonly one will be shown here. Okay, so that it will be easier. Instead of going here and selecting something, you can directly select these tools. Okay, so a few tools are here, a few tools are here. Okay, so as such you have the menus, the toolbars here in which there are a number of tools. Then here you can see the setup, geometry, general, analysis and print, design. These are called pages. Okay, and each of these pages there will be sub pages. So if I get geometry, have a number of sub pages, general, have a number of sub pages, etc. So first I had clicked edit job information, so by default it comes to this page. Okay, if I click the add beam or add plate or add solid, then by default this corresponding page will be opened. Okay, so you have a beam, plate or solid. So as such, by default, if I give the edit job information, or when I give the edit job information, this corresponding default page will be opened, the sub page job. Here I give the corresponding job name. So as I told you, in a large project as such, each corresponding what you call project will have a job. It's called a job. Instead of a project, we call it a job. So you can write that job name here and who the client is, job number. In large companies, as such, what happens is that since there are a large number of projects as such, each project is given a name. Okay, so it will help you to identify. Instead of writing the full job name, it will help you identify, especially when you're saving files as such. It is usually saved in the job number, so that it will be easier for you. So job number, and then the revision. Revision means, you see, each corresponding model you draw it may undergo revisions. Okay, so revision 1, revision 2, revision 3, revision 4. As such, when you have revisions, maybe after discussion with the client or after discussion with the contractor, such, you may have to have revisions in the model. So which revision number is this file? That is what you write here. So if it's revision number 3rd revision file, then you write here 3. Okay, and then you have part. Part is actually maybe a big project as well, as such, may be divided into a number of parts. Okay, there may be a number of structures in one big project. So each of these parts may be given a name. Given a name or a number. So which part is that corresponding part, you can name it. For example, you are having the project of design of a hospital complex. Okay, so in that hospital complex there is actual hospital buildings, there is canteen, there is a number of other features. Okay, so as means a number of other structures that are associated with this corresponding hospital complex. Okay, so as such, the different parts there may be part for canteen, there may be part for the main hospital building, there may be part for the guards room, there may be a part for quarters, etc., etc. The different parts come into picture here. Then comes the reference. Reference is actually, if you are referring to one model as such, this one model may be, in order to understand one model particularly, you will have to refer to a number of other models as such. Okay, there may be interlinkages. Okay, maybe it may be drawings of AutoCAD or whatever it is. So as such, what are the files that will help you to understand the model better? Okay, that is given the reference file. Then the name, file name which you are given will come here, structure.std. By default, .std is the default STAAD Pro file, what you call name. Okay, .std is the corresponding at the end of the file, like .doc we have .docx. So similarly for STAAD Pro it is .std, and then the directory where it is saving, then the date when you have started it. Okay, and the file size is given to you. You can have more information if you want. Okay, that we'll discuss later. And then who is the engineer, who is the checker, who is the approver. Okay, as such these names can be given. By default, the first, when you click open a new file, the default date, today's date 21/2/2021 will be displayed here, and then you can enter the engineer's name and then the date. checker's name, the date, approval person, and the corresponding date when it was approved. Okay, and then if you want to write some commands, you can write the comments here. Okay, so as such, this is the outlook of STAAD Pro V8i. The same thing is available in the Connect version also. Okay, so here job name, client, job number, revision, part, reference, this one comments, but here you have an additional option for Connect project information. I told you, as such, STAAD Pro Connect has a cloud-based system also, where which you can multiple persons can work on a file. Okay, so you can associate a corresponding file to a project that is cloud-based. So what is that ID of that project in that server? What is the name of the project in the server? That can be given here. Okay, if you want to associate, we can associate with the project. Okay, the other in STAAD Pro V8i, only one computer will do a model. Then if another person wants to have the file, then we have to give that file to him by through mail or by pen drive or whatever it is. But in a Connect edition, what is that? There is a central server in which we can save it. Okay, so multiple persons can work on the same project as such. So that is our advantage of a Connect version. So once you give all these and once you click the create button, okay, this corresponding window will be opened. Okay, so the difference, I think it has got a slide. It seems to be stuck. Just hold on. You can see, I'll just tell you the things. You can see that that difference is that instead of what you call the menu bar is same in both, but here you see instead of toolbars it has been changed into a ribbon system. Okay, a ribbon system. Okay, like you have in AutoCAD. So in geometry, it's closed for the time being. Let me select it once again. The STAAD Pro problem is that you need a connection to the internet in order to work this STAAD Pro Connect edition. Okay, this one is a it can work in a remote system as such, but Connect edition you will require internet. Okay, we will wait. Okay, so it has, I'll just click new, just click structure name, I'll just browse some location. For the time being, I'll select this folder itself. Analytical, if I want to, this is not a metric system. Okay, then job information, if I want can write, there is no need for the time being. I'll just write web and then I'll click the create button. Okay, I think the reason is because I should give another place where I can save the file. Okay, I had selected the C drive itself inside a STAAD Pro as such, so I may have to choose another area where I can save the file. Okay, so we'll wait for it to come back. For the time being, we'll continue with this. Okay, so once the entire thing is I'll click once again. A corresponding STAAD Pro software, when it works, you should have something called a connection client. Connection client is a corresponding software with which it connects to the internet. So that is also compulsory as such. This location is the problem. I'll choose D drive, some folder for the time being. Okay, so metric. Now it will not be a problem. Okay, so this is the corresponding outlook of a Connect edition. So you can see here it is like a ribbon, what you call outlay. Okay, a ribbon interface we call it. Okay, you have this called a ribbon in which you have a number of panels. Okay, like you have studied in AutoCAD, it's a ribbon based system. So as such, if you change these corresponding each of these ribbons as such, you will have a number of panels. But here this corresponding thing is constant. Okay, this is not a ribbon based outlook. Okay, So as such, I would prefer to have this V8i outer interface, because it's easier to select the commands in a V8i interface compared to that of a connect. Okay, because selecting the ribbons as such is a bit difficult. Okay, here the thing is that this will keep on, the ribbon is keeping on changing. Okay, however in this one, this corresponding toolbars are constant. Okay, and then if you want more additional tools, you can go to these menu bars as such. Okay, so I think I would work with the rest of the things are same. Okay, just that this Outlook interface has been slightly changed. Okay, so let me, and here you can see this modeling, building planner, piping, bridge deck, post processing, that as such has come into this corresponding way. Okay, instead of coming here at the top here, it has come in this here. Okay, that is a difference here. Another difference. So I'll once this is over, I go to geometry. Now we have to draw the geometry. Okay, now when I click the geometry as such, you see a number of subpages gets opened. We have beam, plate, surface, solid, parametric models, composites, physical members, etc. These corresponding things will get opened. But when I click the, as such, when I click the geometry, a default option called a snap node beam as such gets opened here. Snap node beam is actually used to draw which will help, it is actually a grid system which will help you to draw the corresponding any structure as such. Okay, a grid system. Okay, so as such, a default grid has already been created, that is linear. We can create another grid as such, any other grids. For example, I create a grid for example DEI for the time being, DEI. So as such, and I create a DEI, a corresponding model has been created. Okay, I can edit this. Okay, I can edit this corresponding thing. There are a number of options here. Okay, so I can create multiple grids. I can create multiple grids. For the time being, I'm using the default grid. Okay, if I have multiple grids, I can choose multiple grids like this. Okay, I can rename them. Okay, I can copy them. I can, if I can also import grids also. If you have an for corresponding grid system in an AutoCAD file, I can import the .dxf grid system. Or you have a grid of that is already created in another STAAD software or other STAAD model. So their corresponding grid system can also be imported. So these options are available. For the time being, I'm using the default grid system here. And then when I click the grid system as such, you have a number of options here. Whether hold on, first I will create edit. Okay, you have option for editing the grids. Okay, for the time being, I'll edit this corresponding grid here. So what is the name? The default grid, the plane, which plane it is in. So XY plane, or if you want, you can choose XZ plane, or if you want to choose, you can choose YZ plane. Remember one thing, this view is actually an isometric view. Okay, isometric view here. You can see the corresponding global X, Y and Z direction here. Okay, okay, this actually isometric plane. For to get a better understanding, let me again edit it. XY plane here. Okay, now if I want to see the front view, I come here. Okay, you can view from plus Z. Okay, plus Z means from this corresponding plus Z direction, what is the view. So when I click this one, I'll get this corresponding view. Okay, so similarly, I have the back view from minus Z, from a view from minus X, plus X, the top view, the bottom view, or the last one is the isometric view. So which will help you to, you must have studied about the isometric view in maybe in engineering drawing. The same isometric view is what is available here. So you can choose the isometric view also as such. Okay, so this is actually a system to help you draw. Okay, these are construction lines which will help you draw. So if I see my corresponding cursor as such snaps to the intersection of these grids here, so I can draw a beam from this corresponding point here to this point, etc. Okay, and if I want to escape it, simply click escape. Okay, so this will help you understand the draw. Okay, now as I told you earlier, I can change the grid X, XZ, XY, YZ depending upon which grid you want. Okay, since I already, the model remains same, the model will not change. The grid system, if you want, you can change it. And then the corresponding angle of plane, what angle you want to rotate it. For that, I think I'll view the front view here. And then for example, if I want to rotate about z axis, say for example 30°. Okay, so my corresponding thing will be changed, inclined at a 30°. Okay, as such. Now if I want to say, for the time being I'll make this one 0. Okay, now y direction. Okay, I want to rotate it maybe by 30°. So it will get rotated around this corresponding y direction. Okay, you have here x, okay, y and z. You have here x, y and z here. Okay, so it will rotate around x, around y, around z. To better understand it, we can look at the top view. Okay, so you can see here. Okay, earlier my grid was along this plane. Okay, I'm looking at the top view. Okay, let me show you the isometric view once again, or the front view once again. Okay, I use it at 0. Okay, so this corresponding thing is in this plane here. We can see the top. Okay, the grid is here, and that corresponding beams which are drawn here, that is shown here. If I rotate it 30°, okay, the grid has changed like this, and the corresponding plane is here. I'll do the 3-dimensional view here. This you may not understand as such. It's difficult to get it. Okay, I'll turn by a small degree. Okay, so as such you may not be able to understand properly. It's actually a 3-dimensional view. For the time being I can rotate it. If I right click it, if I use the right mouse, if I use the right mouse and then I press it, the right mouse, and then I rotate slightly, so it will, in which direction it moves, it can move depending upon that direction. Okay, so that is regarding the grid system. And then you can choose an appropriate grid origin. Okay, currently the grid origin is 0, 0, 0. Okay, I'll make this for the time being 0 itself. Okay, and then if you want to change the origin of the grid here, you can change the origin to a point here, 1, 1, 0. Okay, so it has changed the origin. Or I can select this corresponding point, this corresponding tool here, and I can change the grid point to any of these points here. Okay, I can change the grid point to any of these points here, and this corresponding thing will indicate you the construction lines, how much construction lines towards the right and towards the left of the x and y axis. Okay, since it's in xy plane, this shows x and y axis. If I make it xz plane, it will show here x and z. YZ plane, it will show here y and z. So for the time being I'm using x and y plane. So towards the right there are 10 construction lines. Okay, from 1, 2, 3, 4. If I leave 1, okay, there are 10 construction lines. If I similarly I can make construction lines towards the left also. Now towards the positive y direction there are 10 construction lines. Okay, this corresponding window, whether you want to auto save, will come in between. Always give yes. Okay, so you have the corresponding construction lines in the positive y direction. Similarly, you can choose construction lines along the negative y direction by going like this. Okay, and here 1 meter as such indicates the spacing of these construction lines. So I can put here 1.5 if I want. So here you can see along the x direction it is 1.5, along the y direction it is 1. So here I can, depending upon what you want, say for example I can make here 0.5. Okay, so here you can see becomes in 0.5. Okay, you see I'll make this for the time being 0 so that you can have a better understanding. Okay, so here you can have 2.5, 4, 5.57, this 1.5 spacing the grids are. Okay, and this corresponding spacing is a different one. So as such you have now this corresponding origin. You may think that why this starts 0 then 2.5. This origin I'll make it 0 for the better understanding. Okay, so this is the corresponding thing. Okay, so as such 0, 1.5, 3, 4.5, 6, 7.5, 9, as such you can see the corresponding spacing in 1.5 and this one in 0.5. Okay, and then you have the skew angle. Skew angle, if I want to change, earlier I am changing the grid entirely. Now if I want to incline the grid lines, not the entire grid plane but the grid lines, here I can give the corresponding grid. Now for the time being I'll use the front view. Okay, and I'll make a slight skew angle along the x direction with respect to a dash, maybe 30 degree. Okay, so you see the entire x lines has been inclined at 30 degrees. Now for the time being I make it 0. Okay, and now I orient y. I change the angle of the y construction lines. Okay, the construction lines along the y direction. So you see the construction lines along the y direction are now inclined. X is parallel same, but y is inclined. Okay, on the other hand, if this is 30 and this is 0, you can see that x gets inclined but y is still parallel as such, parallel to the initial y. So as such you can change the corresponding grid system here if you want. Okay, I'm not going to much detail regarding the grid system. And then you have options for giving, for example, at the frequency of these grid lines, at what you have options for editing these corresponding values which are mentioned here. Okay, for example, this is too much congested. Okay, if this is too much congested, I can change the frequency of the y direction. Okay, so it will show lesser values. Similarly, I can change the frequency of the other one. And similarly in x, here I am showing only the x values here. Okay, if I want to show x, y and z, it will show all the 3 coordinates. Similarly, along the y direction you can click x and y. The blue in one indicates that it is selected. So all the 3 corresponding points of these grid lines are mentioned. The starting point, okay, the starting point of these grid lines are mentioned here. For the time being, I'll off this, I'll off these two. Okay, so these options are also available, and you have options for axis IDs. Okay, and so here will come x3, x4, x9. Okay, and here y 1.5, y3, y.5, etc., etc. Or you have options for the reference coordinates. So x plus 3, for example, if it is I'll edit the grid here. I'll put a few towards the left. I'll change the angle to 0. Okay. Okay. So here you can see here. I'll take isometric view, time being isometric view. So here's 0. Then you have, sorry, here is 0. Then you have here -3. So there are different ways in which you can represent this one. We are not going to detail regarding that part. And then this snap node beam, as such, you see my corresponding cursor is like this now. So in order to snap it, I have to click this. Okay, then it becomes a snap node beam. So I can click from this point to this point to this point, etc. Okay. Now when I use the snap node beam, the advantage is that one more option is the snap node to existing beams too. If I click the snap node beam here, for the time being, you see this corresponding node here is in between the construction lines. Okay, I had changed the origin here, so it's between the construction lines. So as such, you see, I cannot snap to this node here. Okay, I can snap to this only to the intersection of the grid lines. So if I click this, okay, I can snap even to this corresponding node here. As I told you, this corresponding option will be asked at intervals of maybe 10 minutes, 15 minutes. Simply click yes. Okay, so here now I can snap to this node also, this node. Okay, I can snap to this node also, as well as I can snap to any other intersection of the grid points. Okay, if even in between I can click escape, it will get deleted. So I remove this for the time being. Now remember one thing, when I use a snap node beam as such, the advantage is that both the beam as well as the 2 nodes at the 2 ends are created. Okay, the 2 nodes at the 2 ends are created. That is the advantage of using the snap node beam. Okay, now let me change the frequency to 1 here, and let me edit this grid to 1 in both directions. Okay, and one more, then edit. I'll make this 0, 0, 0. Okay. Okay. Now you see a corresponding beam as well as the 2 nodes are created. Okay, the 2 nodes are created. This is one way in which you can draw. This is actually, the grid system is actually a helping aid. Okay, a drawing aid which will help you to draft the corresponding model. Okay, it is used for drafting. So either you can use the default grids that are available here, or you can also import. Okay, you can also import the models in DXF file or this grid system. You see, actually in buildings, okay, as such, the corresponding grid system will be the grid system that is given by the architects. Okay, so architects as such they will draw the corresponding structure based on their grid system. So usually when we do multi-story buildings as such, we import the grid as well as the model from the architectural drawing, so it will help, it will be easier that time. Okay, so this is one way in which this is grid system is one way in which you can help you draw. Okay, now there is, now when I this create button, you see I told you there is one grid. You have a different types of grids available. You can also have radial grids. Okay, for example, I'll say the name as radial for the time being. Okay, I'll click OK, and then I'll select this radial grid. So you have got this radial grid. Okay, you can edit all the different same things as before we have. Okay, the plane, the angle of the plane, as well as the grid origin, the start angle, the sweep. Sweep means how many degrees. For example, if you are doing 180 here, okay, only 180 degree sweep will be there. Okay, and then what is the corresponding radius 1? Okay, the first radius and the last radius, what should be there. So you can see the radius, it is 0 here, and then you have radius 120 here. For the time being, I use here radius 1 to radius 5. Okay, so a corresponding grid system will be formed with radius 1 to radius 5. So these corresponding different options are available, and you can also have if you create a new grid, you can also have a grid at the top of an irregular shape grid. Okay, which we can name as per our coordinates. No one usually use the irregular grids. Usually people use either linear or radial grids. Okay, so for that's the time being, just basic grid systems are available. Okay, I can delete these two for the time being. There is no such importance of this. Okay, I delete. At a time only one grid will be selected. Okay, you cannot select multiple grids. At a time only one grid will be selected. Now I click the default grid, so default grid opens. So this is one way in which you can start, which will help you to draft the corresponding beams, columns, or whatever it is, or the model as such. Here both the beams as well as the nodes will be created. But now if you want to delete it, simply select it. Okay, now there are two options. So there are two different types of cursors. One is the beam cursor, as the other is the node cursor. If you come to here, you can see here on the left hand side the node cursor and then the beam cursor. Okay, beam cursor will help you select all the beams. Okay, and if I click the node cursor and I click like this again, you can see only the nodes get selected. Only the node gets selected. So you can see here at the bottom, at the close to the cursor of the screen, you can see a round. Okay, that indicates a node. Okay, so as such, there is an option for selecting beams, which is called a beam cursor, and then there is an option for selecting nodes, which is called node cursor. Generally, we prefer we mostly use the beam cursor. Sometimes we'll have to use the node cursor. Okay, now if I select this beam here, and if I want to delete it, I can press the delete button. Okay, in the keyboard I can press the delete button, or I can right click and I can select this corresponding beam here, and then this corresponding thing will be open. Now if I want to view the corresponding beam numbers and node numbers, as such, there are two options. I can press Shift plus B on the keyboard. Shift plus B, it will show you the corresponding beam numbers. Okay, and if I press Shift plus N in the keyboard, it will show you the corresponding node numbers. So beam numbers and node numbers are important. The node numbering and beam numbering will be done as per how you draw it. Okay, on how, based on how you have drawn it, depending upon that, the node numbers and beam numbers will be given to you. Okay, so first we had drawn this corresponding thing. So this node number 1, node number 2, this beam number 1, the 2 and 3 as such. So this is beam number 2, and then you have between 4 and 5 you have beam number 3, and between 5 and 6 you have beam number 4. So if you want to off it, Shift plus B is for beams. I had off it, and Shift plus N for nodes. Okay, so if you want to on it or off it, you can use the Shift command. Okay, now if I select, one thing you have to remember in mind is that nodes as such as got is defined in an STAAD space. Okay, it has an independent coordinates x, y, z. Okay, for the time being, what I'll do, I'll close this. Okay, if I close this, okay, the grid system will be closed, and you will see on the right hand side the different node numbers and their coordinates. Okay, and the coordinates here. So for example, if I want to create a new node number, okay, a new node, I can simply click here and say type here. For example, I want to create a node at say 3, then click the tab button. So the rest here 0 and 0 will come by default. Okay, then if you want to edit it, click 4, tab, and then 0 again. Okay, so a node has been created at 340 here. A node has been created at 340. I'll just shift N, click here, shift N. The corresponding node number 7 is having coordinate 340. Okay, so this another way of which you can draw the corresponding nodes here, and then at the bottom you have beams here. Okay, so here beam number 1. If I click here, if I click here, you can, the corresponding node will be highlighted. You see, node number 1 is highlighted. If I click here, node number 2. Here, node number 3. Similarly, if I click here, this is a beam corresponding table. Beam 1, beam 2, beam 3, etc. Beam 4, etc. It will be selected. Now, nodes as such has got an independent existence. It has got x, y, z coordinates. Beam as such is identified based on the node number. So, beam 1 connects node 1 and node 2. Okay, the starting node is A, means starting node is 1, the ending node is 2. Okay, beam 3 or beam 4 connects node number 5 and node number 6. So node number 5 and node number 6. I'll just on the, I'll click here, shift B. So the beam number is on. So the beam number 4. One problem is that if I on both beams as well as nodes, it will become a bit confusing. Okay, so usually what people do is that they will off the beams. Okay, I click here, shift B, so the beams will be deleted, and then only node numbers is sufficient for the time being. Okay, so you can hear now I can myself create another beam by selecting or by clicking the node number. For example, I want to create a node from between 4 and 7. Okay, between a node between 4 and 7. So I can, now you see there is a difference between in the properties of beam if you start from 7 to 4 and 4 to 7. Okay, if you enter, if node A is 7 and node B is 4, it will be different from if node A is 4 and node B is 7. We'll discuss that later part. So as such, if I want to draw a corresponding beam starting from node 7 and ending at node 4, I click here and I type here 7, then tab 4, again tab. So as such, you see a beam has been created between node 7 and node 4. So this is another way by which you can draw the beam between the nodes here. So here beams as such does not have an independent existence. It depends upon the node. Beams as such does not have an independent existence. It depends upon the nodes. Okay, so as such, for example, if you delete a node, okay, if you delete a node, for example, I am deleting this node number 6. So in order to delete this node number 6, I have to select the node cursor. Then I bring here and I click this node, and then I press the delete button in the keyboard. If I press the delete button, it will ask one node to be deleted. That is this node to be deleted. Okay, and all connected entities will be automatically deleted. Please confirm. That means if I delete this node number 6, this beam, I told you beam does not have independent existence. It depends upon the nodes. So if I delete this corresponding node, okay, this beam will also be deleted. Okay, so they are asking whether if all the corresponding members are connected to this node will be deleted. So if I say yes, okay, not only the node gets deleted, but also the beam gets deleted. Not only the node gets deleted, but also the beam gets deleted, because as such beam does not have an independent existence. Now in case I come here and select the node cursor, beam cursor, and then I click any of these beams. Okay, so and then I delete. Okay, I'm not deleting the node, I'm deleting the beam here. So I click delete. So it'll ask here one beam and associated physical beam, if any, will be deleted. Okay, so physical beam, we'll discuss what physical beam is later. Okay, so as such, when I click OK, this beam gets deleted. But before that, this thing happens, they will ask, deleting beams has left some nodes with no structural elements attached. Do you want to delete these nodes? That means if I delete this beam here, this node 3 as such is independent. Okay, so they're asking whether I want to delete this orphan, means this node here. Okay, or whether I want to retain it. Okay, so if I click yes, the beam as well as the node gets deleted. Only the node in which there is no other structural member going to be attached. Okay, there are no other structural members. Okay, here in this corresponding node there is already another member attached, so this node will remain. But this node, they are asking whether I want to delete this node or not. This is called deleting beams has left some nodes with no structural elements attached. Do you want to delete these nodes? If I click no, this beam gets deleted, but the node remains. Okay, for example, I select this one. For example, I'll select this beam here, and then I click delete here. Okay, and then I click OK. So again, this command comes, deleting the beams has left some nodes with no structural element attached. That means this corresponding node 5, if I delete this, will be independent. Okay, so I can either delete this node or I can retain this node. For the time being, earlier I had retained the node, but this time I will delete the node. So if I click yes, that node gets deleted also. Okay, so remember one thing, nodes has got an independent existence because it has an XYZ coordinate, but beams are dependent upon nodes. So if the node gets deleted, the beam also gets deleted. All the beams connected to a node will get deleted if a node is deleted. Okay, so this is another option by which you can draw it. The third option you can draw is by going here, and then you can, here you see you clicked to geometry. Geometry will help you to draw everything. Okay, all the corresponding commands for drawing will be available in the geometry. Okay, so here there is an option called add beam. Okay, so add beam, you can have the different options are available. Add beam from point to point, add beam between midpoints, add beam by perpendicular intersection. So if I click add beam from point to point, it actually means add beam from node to node. So I click here, and if I come here, my corresponding cursor will change to somewhat like this. Okay, and then I can add a beam from this point to, means I click on this node and then I click on this node. Okay, I click on this node, I click on this node. Now other options are available at geometry, add beam between midpoints. So if I want to add a beam between the midpoints of two beams, I simply click on the first beam here. Okay, and then I click on the second beam. Now remember one thing, when I create a beam in between, what happens is that the earlier two members get bifurcated and a node is created in between. You see, a node gets created in between. So as such, now if you select the beam cursor, this becomes two separate beams. Listen, this is one beam, but as it is divided into two different parts. Okay, it is divided into two different parts. So a node gets generated in between. Okay, and you also have an option for geometry, add beam by perpendicular intersection. Okay, so for example, if I click this and say this corresponding perpendicular means from one node to perpendicularly intersecting the other beam. So I can click this node here, and then if I click this beam here, it will make a perpendicular one. Now you may see that this is not perpendicular because this is an isometric view. If you look at from the front view, okay, you can see that this angle is 90 degrees. Okay, so as such, here also a node gets inserted in between. Okay, a node gets inserted in between. Okay, now you can zoom in and zoom out using the roller. Okay, so you have studied here, and the normal, if you click the mouse center, the roller, if you click the roller and move it, you can pan it like you have in AutoCAD. The same thing is also functions here. Okay, so as such, you geometry, add beam, there are number of options, and you have also option for drawing curved beam. So if I click curved beam and then my cursor changes, so this one node to the other node, if I click, they will ask for the radius of curvature as well as the corresponding gamma angle. For the time being, I'll put radius of curvature as maybe a smaller one, say maybe 8. Okay, and I click OK. A corresponding curved beam is created with a radius of curvature 8 between node number 7 and node number 2. Okay, now of all these add beams, there are 1, 2, 3, 4 options available, out of which the most commonly used is add beam from point to point. So that commonly used one will be available here. You see this corresponding option, the same thing, add beam. Okay, I'm adding between these two. Okay, the most commonly used. Okay, the most commonly used among all these 4 is the first one. So that will be coming, that is put here in the toolbar. So I said you, this corresponding toolbar will have the most commonly used tools. Not all the tools that are available here, but the most commonly used among this will be available here. Okay, so I can directly come here. Similarly, you see this corresponding option here is the snap node beam grid system. Okay, the grid, you can on it or off it by clicking this corresponding thing here. Okay, this is actually just a help you draw. Okay, it does not physically exist. It is just help you to draw this corresponding space here. Okay, so this is the basic modeling part of simple. I just told you how we can draw the beams and nodes. And remember one thing, you also have options for drawing plates, surface, solids, which we'll discuss later. For the time being, at this level only beams we are concerned. Now if you want to delete all the corresponding elements, you simply select like this. Okay, select a window like this and then click delete. Okay, so 11 beams, there are total number of 11 beams here, they get deleted. Okay, and they'll ask their number of nodes, whether I want to retain those nodes or whether I want to delete it. So I click, I want to delete it, yes, so all the nodes will be deleted. You see, the numbering system is actually a continuous numbering system. So once I had deleted all the beams as such, the numbering system next number, okay, as such I can type here for the time being, for example 0, 0, 0, and then I'm putting here 4, 0. Okay, so I have a corresponding beam node 1 and node 2 here. I choose I click here, I choose isometric view. Okay, and then I put node number, a corresponding beam between node number 1 and node number 2. Sorry. Some error is coming. For the time being, we'll delete this one. We'll start from using this. Some error has occurred here because some issue has come here. Okay, we'll save the file for the time being, and has been regenerated. Okay, now it has, so now in node number it has started from 16. Okay, what happens is that sometimes what happens is that when you start deleting the things, okay, the numbering, as those numbering will also be deleted, and then the rest will be continuing. Okay, so as such the nodes has started from the beginning, but beams has started as continuous of the older one. Okay, so these are the basic things which I would like to say in this corresponding. Now we'll go to the next part. Okay, so geometry, there in the geometry page we have discussed beam. Rest, if you want to draw a plate, you can click plate. Surface, you can click if you want to draw surface. When you click each of these, you see the dialog box here at the right end will change depending upon which you are choosing here. Okay, which element you are choosing here, depending upon that the dialog box here on the right hand side will change. Okay, so since in our question here it is a beam we are drawing, so I am concerned with only a beam here. Okay, now after the geometry, the next page, okay, these are sub pages. This is the main page, the sub pages. So the next page here is general page here. So when I click the general page here, Then you have this general page has got a number of sub pages. You have page for property, specifications, okay, support. When I click each of these, this dialog box will change. Okay, then loads and definitions, then material. Okay, so first we click on property. So property is actually assigning the corresponding sectional properties of the beam or whatever beam surface, whatever you're drawing. Okay, if you're assigning the sectional properties, if it is a beam, then you have to assign sectional properties of beam. If it's a plate, you have to assign sectional properties of plate, etc, etc. So first, when I click the property button here, you can see the corresponding window dialog box changes here. Okay, we have got section, and then we have got another tab called beta angle. So section as such refers to the different sections you can we can bring into the STAAD Pro, and then we can assign this corresponding thing to here. So first we will there are a number of options available here. Okay, so first what we will do, I'll edit, delete, values, section database, define, materials, thickness, user table. Okay, so first for the time being I'll choose a define. So when I click on the define, another dialog box will open here. Okay, in which different types of sections are available here. Circle, in which circle you have the corresponding option for diameter. Rectangle, in which you have the option for the depth as well as width. Then you have corresponding T section, trapezoidal section, then general section. For example, if you are not concerned with the type of the shape of the section, but if you are concerned only with the properties, okay, the AX, AY, AZ, and the IX, IY, IZ as such, depending upon that we can enter those values. Okay, then there's an option for tapered eye section, then tapered tube section. In tapered tube you can select a different types of tubes here. Okay, and then at one end what is the corresponding diameter of the tube, on the other end what is the corresponding diameter of the tube. Okay, so if a beam, these are tapered sections. Okay, so as such from one end maybe the diameter of the tube will be, for example, 3 cm. On the other end the diameter of the tube may be 5 cm, and then you can specify thickness. So thickness will remain constant, okay, but the diameter will change. If you want, you can create such tapered tubes. Okay, so it can be round, it can be hexagonal, it can be square, anything. Okay, and then there's a provision for assign profile, which we'll discuss later. So when I click any of these, okay, as such you can see the corresponding material properties also are clicked here. Okay, so by default both the corresponding sectional property as well as the material properties can be assigned here in one go. Okay, but I prefer not to enter material properties right now. I usually unclick this one. Okay, whenever I enter these values, I want to unclick this one. So this corresponding way in which you can select number of options here. So first I click circle. Okay, and then for example you see the metric system, we have selected the metric system, so as such the units here are meters. So if I want to create a beam or a column of 300 millimeter dia, so I'll put here 0.3. Okay, I unclick this material and I click this add. So when I click this add, you see here this corresponding circle gets generated, or it gets loaded into this corresponding area. Okay, then I can do multiple. I can say a rectangle, then I put here for example width, I say depth is say for example 0.4 meter and width is maybe 0.25, and I unclick this. Okay, and now if I want, you can click also. If you already know the corresponding material property, you can click this. For example here, for the time being I am clicking the material here and I click here add. So here the second gets loaded into this space here. So here you can see the material has been defined here. Here the material has not been defined here. Okay, so once you have added all you want here, okay, whatever sections, because in a structure there may be multiple types of properties. So all these are sectional properties, okay, not material properties. Okay, all these are sectional properties. So once in which you can assign material also, but as such there is no need for assigning material at this stage. Okay, so once you have added all what you want, you close it. Okay, you close this one. Okay, this one way. This define a section is usually meant when you're in which we want to define a particular type of section. Like in concrete, we want to define the width and depth. But sometimes what happens is that in case of steel sections or aluminum sections, cold form steels, aluminum sections, then IS code or all the different country codes has provided standard sectional properties. Okay, like I section has got certain ISMB 300, ISMB 400, etc., etc. There are standard sections. So in order to get those standard sections, in order to load those standard sections into the space here, we click the section database here. So when I click the section database here, a window will open here. Just wait a minute. Here. So a window will open here in which all the different sectional properties will be available to you. That is available in different codes. For example, in the first one, there is steel. Then you have option for cold form steel, then timber, then aluminium. So in steel, for different country codes, American, Australian, Brazilian, British, Canadian, Chinese, Dutch, European, even there is also Indian. So all the corresponding standard steel sections that have been defined as per their codes, as per their Bureau of Standard codes as such, these will be available. For example, if you go to Indian code here, if I click the Indian code here, and depending upon number of shapes here, for example, I am using a channel section. So all the standard channel sections that are available in the code, that will be loaded here. So you can select any of these and load into the space. Okay. Now if I want to see more properties of this, I click one of these sections, for example ISMC 75, and I click the view table. I'll get all ISMC 75, all the corresponding names, sorry, all the corresponding properties that is given in the code. Okay, that is given. Just drag this to the right. So including what is the corresponding sections of the channel, the shape, everything will be displayed here. Okay, for all the, if you click, for all the different channel sections, all the different channel sections. Okay, so you click any of these section and then click add, that corresponding thing will be loaded into this. Here also by default, okay, the steel gets selected. So if I want, I can delete this also. Okay, not delete, I can unclick this if I want it. Okay, and that too, you see, for example, each of these sections, there are a number of ways in which you can do it. For example, in case you are selecting channel section, for the time I am using channel section here. So in a channel section, I can use a single channel section. Okay, one channel section like this, or I can choose two channel sections that are back to back. So one channel like this and one channel like this. So both the properties as such will be assigned as one single entity. Or I can choose a double channel section front to front. That is also available. Means one channel like this and the other channel like this. Like it will become like a box type shape structure. Okay. So these options are also available for you if you want to load these into the corresponding thing. So this is one thing. You can load multiple sections. Now, for example, we can put angle sections are available for you. So ISA 25, 25, you can load it. In angle sections, you have either single angle, then single angle with reverse YZ axis. Okay, you can change the axis. Okay, then long leg back to back, means two different angle sections with their long ends back to back, and then the two different angles, same angle. Okay, same 25, 25, 5 with their short leg back to back. Okay, I hope you understand what is long leg back to back and short leg back to back. Okay, and then you have option for a star arrangement. Okay, they'll long is like this, one like this and the other like this. Short is like this, and then star will be somewhat a star shaped. Okay, star shaped something. So these things are available to you. As I shown you with my cursor, these things are available to you, and when you can load it whatever you want. Okay, okay, and then if you're having, even that too, if you're having a long or a short angle, we can give a spacing in between them. Okay, small spacing in between them also, it's possible. Now if you click the view table, okay, you can get each of these properties that are available to you. Okay, and this select sectional database we'll discuss later for the time being. Okay, remember one thing, and the STAAD Pro software, there are large number of options. It is not possible for a person to teach the entire option in maybe in a course. So the most commonly, my main aim is to help you identify the interface and how you can model simple structures in STAAD Pro software. Okay, just give me a minute. I just okay, fine. Now we shall go into so now you can select multiple, you can have multiple sections also. Okay, one you can put Indian code, the other you can put Chinese code, multiple. This is available for steel. Okay, then cold form steel also, if you want cold form steel, here also you can have Indian cold form steel sections are available. Okay, and then okay, this you can see different sections are available in cold form steel, and then you can have timber in timber. American code as such has given, and Canadian one is there. Okay, as such in Indian code there is no timber sections. We prefer that it is dependent upon the requirement at site, so we don't provide as such. And then aluminum also, in this corresponding STAAD Pro software only American code has been included. Maybe in the higher versions the other codes will also be included. Okay, so with this once you have loaded all that is what you want in this space here, you click close. Okay, now what I do, let me draw a few beams as such. Let me go to, I will click the create snap node and I'll draw a few. Okay, I click escape. Okay, and I come back to geometry, sorry, general, property, then this corresponding thing. Okay, so you see these three sections has been loaded into space. Now remember one thing, there are two things in STAAD Pro in when you click properties, where you click properties or supports, or each of these things in general subpage has two steps. One is defining it and the other is assigning it. Okay, so one is defining, in which we mentioned the sectional properties of thing. The second is assigning these properties to each of these members. So which member is which? Okay, that can be given at the bottom. You can see here assignment method. Now one more thing, you can I told you define as well as section database. If you are using plates, okay, you can click this thickness, okay, in which will help you to define plates and surfaces. So plate, there's an option, 4 nodes are there, so you can have different thickness at these 4 nodes. Surface is very thin element, so as such all the corresponding nodes will have the same thickness. Okay, there's a difference between plate and surface. Plate has the corresponding shear in a plate element. The variations of shear in the local z direction is also takes there, but surface is a very thin one. Okay, so here the corresponding shear as properties as well as displacement properties in the z direction, that is perpendicular to this, will not be taken into account. Okay, so you can even put plate. Okay, in this corresponding model here there is no plate here, so I can avoid plate here. If you want, you can add a plate here. For the time being, if you click close here and you go to geometry and you click here plate. Okay, you click here plate, you can have an option for selecting the plate here. So plate 20, you can select node number A, B, C. If you go to the right here, D. Okay, so I can click a plate between 2, 3, 4 and 5. Okay, so I put here 2, 3, 4 and 5, and I click tab. A corresponding plate is formed. You can see a green colored thing. This is called a plate here. If you want to select a plate here, you click here and use the plate cursor, the third one. Okay, with this you can select a plate. So if I click the beam cursor, I can select only the beams. If I click the node cursor, I can select only the nodes. You can see these nodes gets highlighted in red. Okay, if I click the beam cursor, I can select only plates. Sorry, not if I click the plate cursor, I can select only plates. Okay, so this one. Now there's also other option. You can always save in between when it comes. There's also other option. You can go to geometry. You can click add plate, in which you can, there are two types of plate here, either quadrilateral plate or triangular plate. For the time being, this already quadrilateral plate. For the time being, I'll use a triangular plate here. So my corresponding, this one will change to plate here. So I select node number 1, node number 2, and node number 3. So a corresponding plate is formed here. So if I click the plate cursor, I can select this plate, or I can select both these plates here. The beams will not be selected. Remember one thing, the beams, I have beams here. Okay, if I select the beam cursor, you can see that I have beams like this, like this, like this, like this. Okay, and on top of that, I have also these plates here. Okay, and you can, this option is usually plates as such, the most commonly used is quadrilateral. So as such, this corresponding quadrilateral plate can be added by using this tool. This after add beam here, this add 400 plate is also available here. Okay, so we'll come back to general. Okay, so I told you you can even add plates here. So thickness, for the time being, I'll add a plate here 0.1, and I click here 0.1 first. Okay, all these corresponding values will show here 0.1, 0.1, 0.1, 0.1. But I can change here later. I can make this 0.5, maybe 0.5, maybe 0.1. Okay, for the time being, I am removing the material and click add. Okay, this corresponding plate is formed here. Close. So define section database thickness. Okay, and then if you click materials, as such, the different material properties by default what is given in the STAAD Pro, that will be shown here. Okay, now if I click values, as such, if I all the corresponding things you have loaded here, okay, that will be shown here. Okay, you have selected first prismatic circle, it is shown here in one tab. Then prismatic rectangle, all the properties is shown in one tab. Then the channel section you have selected, all the properties are shown here. Then the plate thickness, if you click here, the corresponding plate thickness, all these things will be shown here. Okay, you can close this, you can close this. Okay, so that as such, when you click values, that thing will be opened, and then materials, the corresponding material properties will be displayed here. Okay, and then you have got a user table. This one we will discuss for timing later. Okay, and then you have options for editing it. Okay, now when I click edit, I can only, for example, I'm clicking the circle. Here when I click edit, I can only edit the diameter and the material property. I cannot change into a T section or another section as such. Okay, the dimensions as such can be edited. Okay, if I click edit here, the dimensions as such can be edited. If I want to delete something, I can delete this one. For example, if I want to delete the circle, I click here delete. They'll ask if you want to delete it. Okay, that has been deleted. Okay, and here you can see the reference number 2, 3, 4. Okay, the first one was reference circle 1. Okay, that I had deleted it. Then we have 2, 3, 4, etc. Okay, so this just for we'll look into that reference number as such. And then we have beta angle, that also will come in later. So I told you first thing is that you will have to load the corresponding different what you call sections which you want into the space, and then the next step is to assign these things to the corresponding elements that are available in your model here. Okay, so here at the bottom you have got something called assignment method. There are 4 different types of assignment methods. Okay, assign to selected beams, assign to edit list, use cursor to assign, and assign to view. Okay, so these 4 different assignment methods are available to you. Now if you, the most commonly used is use cursor to assign. So what I do, first I select which one I want to assign. Okay, which section I want to assign. So first I select this one, rectangle 0.4 to 0.25, and then I click use cursor to assign here, and then I click assign. So when I click this assign, it changes into assigning. Okay, now when I bring my cursor into this corresponding space, my corresponding cursor will change to this format. Okay, shape of an eye, and then I keep my cursor close to where the beams are, where I want to locate. Okay, and then I click here. For example, there is a beam between 1 and 2. So when I click here R2, that means this R2 refers to this R2. Okay, then here there is a beam here R3, sorry, R2, R2, R2. So there is a beam like this, like this, like this, like this. Okay, Now if I click it once again, hold on, see, if I click this, you see, since it has been assigned, that will be indicated in red. Since this has not been assigned, nothing is shown here. Since this has not been assigned, nothing is shown here. Okay, so rectangle, you see, this corresponding thing has been assigned here. Okay, similarly, I can assign a plate like this, then it will be like this. So if, for example, I am assigning this plate here, so I had assigned this plate here. Okay, that is another way. Now if I am assigning this one, okay, if I click this, you know, once this is in the assignment mode, okay, once this is in the assignment mode here, I can change this, and if I can change this also. For example, I want to make this one as R3, means ISMC 125. So I click it here, I bring my this one here, and I click on this once again. So now R2 becomes R3. Okay, so if you assign one on top of the other, the old gets deleted and the new gets assigned. Okay, now this is one method. Now there is an option called assign to selected members. For this, I first off this one. Okay, so it becomes into assign itself. Now I select all the beams or which entity you want to assign. I first select. So first select and then I assign it. Earlier was first I click which one I want to assign and then I use this place. So here, for example, I want to click make this beam and this beam. So I select this one, then this beam I select, and this beam I want to make it to R3. Okay, remember one thing once again, first I have to select here. Okay, so I select here ISMC 125. Now I want to make this beam as well as this beam as ISMC 125. So I select all the members I want. For timing, I'll select also this. Okay, now this assign to selected beams will be open to you. Okay, so now when I click assign here, they will ask whether you want to assign this, do you want to proceed. So when I click here yes, so this also get into R3. Okay, so now the rectangle, nothing is there here. Okay, but here everything has been changed into R3. Okay, and then another option is by using the edit list. Now before the edit list, assign to view. Assign to view means that entire thing will be assigned. Okay, all the entities in this member will be assigned. For example, if I click R2 here, okay, R2 here. Now there are 5 beams here. 1, 2, 3, 4. Sorry, 4 beams here. So I click this one and I click assign to view. As you can see, everything is R3, 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 R3. But now I want to make it to R2. So I click here R2 here, and then assign to view. I click assign. The assignment method you have chosen is assign to view. Do you want to proceed? Yes. So as such, all the corresponding entities within this view will be changed into R2. That is a function of assign to view. Means everything will be changed into R2. Now there is an option called assign to edit list. Now before I go to assign to edit list, you will have to, I told you that all the corresponding members as well as elements are numbered. Okay, plates are numbered. For example, if you want to view here you can see the node numbers are visible. Okay, I'll off the node numbers. So Shift N. I click here, Shift N, the node numbers are off. Shift B, the corresponding, you see 70, the corresponding beam numbers are indicated here. Okay, so 16 R2, 17, 18, 19. Okay, earlier it was different, but when I click the property section, it will change like this format. So 17 double colon, then R2. Now if I want to view the corresponding plates here, Shift P. Okay, Shift P is for viewing the plates. So here this plate has already been assigned at R4. So as such 21 semicolon R4, but this plate has not been assigned. So this, as such, this shows only the plate number 20 here. So as another way of assigning is by using these beam numbers. For example, here now you see everything is this corresponding R2. If I want to make any two of these R3, for example, I want to make 17 and 18 R3. Okay, so I click here ISMC is 1, and I come here and I write the corresponding beam numbers here. beam or plate or whatever you want to change, that numbers here. For the time being, we are using a beam here, beam member here. So I click here and I write 17. I'll save it for time being. 17. You can put either comma or you can put space. Both are the same thing. 17 space 18. Okay. So I put assign to edit list. I write the numbers of the beams I want to assign, and when I click assign, those corresponding beams will be changed. Okay. Those corresponding beams will be changed. Okay. So there are 4 different assignment methods: assign to selected beams, use cursor to assign to edit list, and assign to view. Okay. Now there is one plate which has not been assigned here, so I will write here 21 as such. You see, when I click plate thickness, 21 has already been given here, since 21 this plate is 21. So I come here, okay, space, and I give here 20, and I click the value assign. So this corresponding plate is also been assigned 20. Okay. For the time being, I am if I want to delete these 2 plates here, for the time being, I can click the plate cursor. I select this plate. I press the delete. They will ask whether I want to be deleted. Okay. So that plate is deleted. If I want to delete this plate, I click here. Okay. I can click delete. So as such, that plate will be deleted here. Okay. And this one I click here. That 20 and 21 as such, it is earlier written here, that has been gone because I had deleted both these plates. If this I want to delete it, I can click here delete, and then that corresponding will be deleted. Okay, now you see 2 are rectangular section 0.4 and 0.25, one is ISMC. Okay, even in ISMC, the thing is that when you click the edit button here, I can, in this option, I can change the section also, which ISMC you want. Okay, which channel section you want. A number of things are available to you. So I think all of these has been discussed. User table, we'll discuss it later, and then you have an option for beta angle, which we'll discuss later. The next is specifications, which I will skip. We'll discuss it later. And then we have something called support conditions. Support conditions is like you are defining the supports. Okay, you have to define the supports. So as such, if I want to assign maybe fixed support or any other support, you can use this corresponding condition. You remember one thing: support conditions are assigned on nodes. Okay, so as such, you can see my corresponding cursor will change into a node cursor. Okay, by default itself. Okay, so there are 3 options: edit, create, and delete. So when I click create, okay, you can see this corresponding window, and you can see different types of support that are available here. Okay, for the time being, when I click the fixed support, okay, it will show you the corresponding restraints here. So in a fixed support, fx, fy, and fz, okay, by default means there is no movement along 3 directions. So there is already an fx in the corresponding place. There is fy. This fx force will be there, fy force will be there, fz force will be there. Fx, fy, fz refers to the corresponding reactions in the 3 directions. Okay. Okay, fx the horizontal reaction, vertical reaction, and the other fz the reaction in the direction. Similarly, mx, my, mz refers to the moment reactions at the 2 ends. So in a fixed support, okay, you will get all the reactions in the 3 directions as well as all the moment reactions in the 3 directions in a fixed support. And when I click a pin support, as such, you know, a pin support, it cannot displace horizontally or vertically, but it can rotate. So as such, fx, fy, and fz, already you will get the values of fx, fy, and fz, but mx, my, and fz are not clicked here. That means these 3 values are 0. Okay. So as such, you have fixed here and a pin connection, or pin join, fixed join, or a pin join. And then you have a number of other options also, which we'll discuss later. The most common one which I want to discuss is the fixed but condition. So in a fixed but condition means we say that a corresponding node is fixed, except you can release one. Now remember one thing, I am providing a release. Okay, I'm not providing a support here, I'm providing a release. For example, I want to make a roller support. Okay, a roller support is actually a release in one direction. For example, in this corresponding figure here, if this corresponding node A is a roller support, if this N is a roller support, that means there will be only be Fy. Okay, if it is a pin support, there will be Fx, Fy. I'm avoiding the Z direction because this is a structure in a single plane, so I'm avoiding the third direction. Okay, so you have here Fx and Fy, and here Mx, My, Mz is 0. In this corresponding here, point A, B or node B, Fx, Fy, I'm avoiding Fz, and you will have here Mz also. Okay, Mz, Mx and My I'm avoiding for the time being. So if I want to make this node A roller, that means I have to release the corresponding reaction in the horizontal direction. Means this should be able to move in the horizontal direction. So for that, what I do, I take the fixed but condition, I click this. Okay, that means I want to release the corresponding force or reaction in the horizontal direction along X. So this means a roller which can move in this direction. Okay, if I'm assigning this to this node, a roller which can move in the X direction. If I put this here Fy, a roller which can move in this direction. Okay, if I put here Mz, a roller which can move in this direction. Okay, as well as you will have to provide Mz also, because if I want to make it pin joint, a roller means it's actually a roller with a pin joint. Okay, so if you'll have to click Mz also. So if I want to make a roller in the X direction, I put Fx and I'll release Mz. Mx and My will not have any importance when you're taking a planar figure. So when you're taking a three-dimensional space figure, then Mx and My will have importance, otherwise it will not have any importance. Now there is an also option for defining the stiffness. Means it is not fully free. Okay, if you want, you can say that as such, you can specify the stiffness in certain directions. Okay, for example, Fx it is fully free, but Fy, Fz, Mx, My is not fully free. Means it is fixed here, but instead of that, instead of pure fixity, I can provide a stiffness. That means if a corresponding depending upon the force here, it may slightly move towards the say if you're putting Fy, depending upon what force is applied, it may displace slightly. Okay, stiffness. Okay, that can also be provided. I hope you understand stiffness. Otherwise, you can ask me personally. Okay, I'm not going into much detail regarding this part for the time being. Okay, just remember one thing: if I want to make a roller support in the X direction, then I put Fx and Mz. In the Y direction, I put Fy and Mz. Okay. So for the time being, I'll create a fixed support, add. I'll create a pin support, and fixed support and pin support, simply click this one and click the button add. So it will become added here. Then once again here support, here also there are 4 different types of assignment methods as I told earlier. Okay, so support 2 here is fixed support. I click here, use cursor to assign, and I bring my cursor to this point. You can see the cursor changes. So I bring it to this node and I click here. Okay, or what I do, I click the node cursor, I select a node like this. Okay, and for example, I want to assign this node roller. So first I come here, I select, sorry, I want to assign this one as pinned. So I click here. Okay, then I select this node here, and then I assign to selected nodes here, and I click assign, and then yes. So the corresponding pin support is given here. Or I can put, for example, I create another support. I want to create a roller support. So I use a fixed but condition. I put Fx and Mz, and then I click add. Okay, and then I click here. Use another, we will put what, edit list. Okay, we put edit list. Now here in the edit list, what you do, it is like instead of putting the beam numbers, you'll have to give the node numbers. So I will off the beam number, shift, I'll click here, shift B and shift N, I'll on the odd numbers. So I want to assign roller support at this end. So this corresponding node to I want to assign roller support. Okay, so I come here, assign to list, and I click here 2 and I click here assign. So something called this corresponding thing will be assigned. It will not properly show you a roller, it will just show you something. It will show you corresponding fixity and the corresponding moment release, where it is. Okay, that means, let me, along the y direction, okay, it is let me show you. Okay, you see along fx, it has a release. So along fx it is shown something by red, and along fy, fz, fsin it has some fixity, so that is shown here. Okay, it will be easier to identify roller support in a STAAD Pro, but it is you will have to properly understand how to assign roller support. Okay, so this is how you assign roller supports. Okay, and then is the load definitions. Okay, load definitions as such, there are two things here. One is definitions. In certain loads you will have to define, okay, what type of load it is. For example, vehicle definitions will be there. If you are using earthquake loads, earthquake definition will be there. If you are using snow load or wind load, pushover analysis, certain loads will require definitions, certain loads will not require definitions. But in this case, if you are assigning only simple dead loads and live loads, there is no need for definitions. So for that case, I don't need require this definition, so I put this, click this minus sign, and I click this load case. Load case means the case, means dead load, that is a load case, live load, that is a load case. Okay, so I click here load case here, details here, there is an option for new add here, so I click here add. So as such, a window box will open in which there is an option for primary load case. So the first load number, what is the name of the load case you want to provide. So if I want to provide dead load, I can put here BL for the time being, and loading type what you want, whether it is dead, live, etc. This is very important if you want to give load combinations. Okay, you have option for providing combinations here. Okay, so when I click this and I click here add, a corresponding DL, load case 1 DL will be created here. Okay, then this becomes number 2. Already 1 has been over, so number 2 comes here. For the time being, I'll put it LL, live load here. Okay, and I make this one live. Okay, and I click here add, so a live load will come to picture here. Okay, similarly you can have operation of load generation, which we'll not discuss right now. Then you can define combinations. Okay, so here load number 3, the combination you want, load combination 3. For example, I'll name this as 1.5 DL plus, this is the name. Okay, I can provide anything what you want, 1.5 LL. Okay, so what type of you want? We want normal type. There is also SRS type and ABS type, absolute value and square root value. For the time being, we want normal value. Okay, so what is the factor you want? Okay, AI into L1. So the first I click the dead load. For the time being, I'll make this one 1.5 instead of 1.5, put it 1.3. Okay, so I click here dead load here, and I write the factor here 1.5. Okay, and I click this right button, this right single one. Okay, this angle bracket towards the right, I click this. Okay, so 1.5 times load case 1. Load case 1 means this one. Okay, that is DL, 1.5 times. Okay, and then I change this to 1.3. Okay, and I click here and I click here, becomes 1.3 here. So 1.5 times dead load, 1.5 times load case 1 and plus 1.3 times load case 2. Now these options are also available. If I can click bring both back here. Okay, bring both back here, come back here. Now if I want both 1.5 here, I can click 1.5 here, and instead of clicking this one arrow, I click this 2 arrows towards the right. Okay, so all the things that is available here will be transferred to here, and they will be multiplied by 1.5 here. Okay, So I'll take this one. I'll bring it back here. I put here one arrow towards the left, and I put here 1.3, and I click here and I bring it towards the right. So this is 1.5 and 1.3, and I click here add. So here you can see the load combination. Here L indicates the primary loads, okay, and here C indicates the combination load. So C as such, the load case number 3 is 1.5 times load 1. Load 1 is this, okay, sorry, this 1, and 1.3 times load 2, that is L at here. Okay, this is defining only the load cases. Okay, now if I want to add more load cases, I simply click here. Don't click here. Okay, click here and then click here add. So as such, the primary, the defined combinations, and also you can put auto load combinations that is available as per Indian codes, Indian or any country code. So if I, for example, I can select, for example, in this you can see the corresponding Indian code here, okay, and what type of structure, whether it is general structures or plastic structures as such. Okay, so depending upon what you had defined here, so you have defined here dead load and live load, and depending, since you have defined only dead load and live load, all the load combinations, okay, for dead load and live load as per the IS code will be generated. So when I click here generate loads, okay, these corresponding 4 combinations are available. These combinations include both, okay, the ultimate strength as well as serviceability. Okay, both the combinations for ultimate strength as well as serviceability will be come here. Okay, and whether you want to add all of them or whether you want to add only selected of them, you can choose. Okay, so for the time being, I can take some of these towards the left. If I don't want it, I can take towards the left. Okay, and only these I want to assign, I can click here assign and become towards the right. Okay, so you can 1.2 into 1, you can read this one, means the corresponding load combination 2, this load combination 1, load combination 2, load combination 3, these 1, 2, 3, 4 indicates the auto load combination. Okay, as such, when I bring to the right, 1, 2, 3, 4 indicates auto load combination. For the time being, I am putting 1 and 2 to the left. I don't want ultimate combination, I want only serviceability combination. Okay, so auto load combination 2 is 1 space 1.2, that means load case 1 1.2 times, and then load case 2 1.2 times. Okay, and the next one, auto load combination 4 1.9, that means dead load 0.9. So if you refer to the Indian code, there is a table that is provided, IS 456, there is a table provided in which you can see the combinations for both serviceability as well as ultimate state. So you can set these two. For the time being, I am adding only these two. Okay, so when I click here add, you can see a generated Indian load combination. Okay, 2. Okay, this 2. Okay, load 1.2 times load 1, this one, and the other one is 0.9. Okay, so this is the first, hold on. So this corresponding value 1.5 is we had defined our own combination. The rest is as per the Indian code here. Okay, then there is an option for load envelope that we'll discuss later. Now this we had defined only the load cases. Now we have to define what are the loads that are coming on the corresponding structure as such. Okay, in each of these cases, for example, dead load, I click here. Now I don't click here, but I click here. In this dead load, what all things are there? Okay, so I click here add. So a different dialog box will get opened. Okay, in which you have an option of providing self weight. Okay, you have provided for option loads at the nodes, and there's also option for providing support displacements, and then you have option for providing loads on members, in which uniform force or UDL, uniform moment or that moment that is continuously throughout the beam, then concentrated force, concentrated moment. I'll bring it to the top here. Linearly varying load, okay, trapezoidal load, hydrostatic, pre or post stress, okay, and fixed, and large number of things are available. Okay, so if I click uniform force for the time being, for the time being, I'll start with self weight. Okay, self weight as such, you see, when we apply loads, we have to also indicate in which direction they have to be provided. Okay, so all the corresponding, for example, if you are defining loads for nodes, okay, or self-weight, it will be in one direction, whether it is in the global x direction, global y direction, or global z direction. Okay, since self-weight is towards the earth's surface, and we have taken the value of means our structure is assigned that the y direction, the negative y direction indicates the direction of gravity. So I put here y and -1. Okay, means when I click here self-weight, what happens is that the computer as such, or the STAAD Pro as such, calculates the corresponding material weight of all the members. Hold on. Of all the members that has been assigned here, okay, based on its density. Okay, and all these loads will be in the negative y direction. That is why factor -1 is given. Okay, here x, y, and z. So y direction, okay, y direction is positive. Okay, but to make it in the negative downwards, I put here -1. By default, it will be -1 itself. Okay, that means the corresponding forces are acting in the downward direction. Okay, so self-weight as such, the computer itself will calculate the weight based on the section you have provided. Based upon the density you have provided, it will calculate its own self-weight, and by default it will provide. There is no need for us to calculate the density as such, or to calculate the load as such, okay, due to self-weight. Now nodal load here, if I want to provide loads at nodes here, means at this node, at this node, at this node, at this node, I can provide the node, and that too fx, fy, fz in all three directions. That is the point, means at three directions, as well as the corresponding moments. If I want to provide a moment, load in the form of a moment, I can provide these in the at nodes. Okay, and then you have provide option for providing support displacements. Okay, means how much it is displacing. You must have seen about cases of support displacements in structural analysis. So I can provide support displacements whether it is fx, fy, fz, means it is settling along the x direction, y direction, or z direction, or I can provide how much degrees it has rotated. Okay, support displacement, how much degrees it has rotated initially. Okay, that's also option. Then member load, as you know, you can provide member load, okay, as UDL, uniform forces UDL. So D1, D2, D3. Okay, D1 indicates the starting, okay, when the load will start. D2 indicates from the starting till the point where the load is stopped, and D3 indicates where the load should be provided along the corresponding section, either in the exact center line or slightly displaced. Okay, for example, I provide here say -3 kN per meter. Okay, D1 say from 1 meter till 3 meters. D3 for the time being I want to place it along the center line. Okay, and that too I can place it along the local direction as well as the global direction. We'll discuss local and global later. Okay, for the time being I am referring to global direction. So I want to provide in the, why I have given minus is that I want to give in the downward direction. So minus means in the global y, positive y direction is upwards. If I put negative, it will become downwards. So here when I click here add, for the time being when I click here add here, what happens is that corresponding load will be coming here. Okay, with a question mark, since it has not been assigned, it will give a question mark. Now for example, I can also add self-weight here, and I click here add, it will become, all will come under DL. Okay, since you are in DL, all the loads which you give here will come in DL. If I want to provide some maybe 3 kN force here, I provide here add, this will come here, and maybe for example MZ I am providing say 2 kN meter. Okay, I click here add, so all this will come here, and I finally click close. Then these loads has already been defined. Next is assigning. Okay, now we'll do some live loads also. I'm just giving you some random idea. Okay, it's not exact loads, I'm just giving you some random idea. I'll click here add. Now instead of we have already given self-weight, nodal load, member load, we have given uniform force. If you want uniform moment, you can give here uniform moment, for example here. Now if I put for example 3 say global direction 3 kN per meter, And then if I don't put any value here, 0 0 0, all these are 0 0 0, okay, that means that the entire beam as such will be assigned that load. Instead of starting from one point to the other point, the entire beam, if I give this 0 and this 0, the entire beam from one end to the other will be assigned the same load. So I give all these 0, that in the global y direction. I click here add. So as such you can see here uniform moment, okay, in the global y direction. Okay, then a concentrated force. Okay, concentrated force, say for example I provide here 3 kilonewton in the global x direction, for example. No, sorry, global x direction. Say d1 at a distance of maybe 2 meters. Okay, okay, so d1 at 2 meters, d2 as such, if you d2 here indicates along the center line if there is any displacement. Okay, for the time being it is along the center line, so I click here d2 is 0, or if I don't put 0 also it will consider it to be 0. Okay, add. Then concentrated moment. If I want to provide a concentrated moment, this member load is for giving loads within the members, not at the nodes. Okay, within the members. Now here for example I provide here 4, maybe at the distance of say 1 meter. Okay, maybe in the global moment as such will be provided as such in the global z direction. Since you are having a planar figure, the moments, if you are providing corresponding forces in a planar figure, for moments it will be in the global z direction. Okay, we'll discuss what is global z, global y, etc. later. Okay, so for the time being, just make I'll make you understand what is global z, global y later. Okay, I'll click here add. Okay, and then we can have a linearly varying load. Okay, so from one end it is starting at 2 to the other end it is starting at 3. Okay, in the global, this one will only be in the local direction. It is not global direction, there is only local direction. Okay, so I'll put in the local y axis, I'll put here add. Then I'll put a trapezoidal load here as such. For example, I'll put here maybe 5. Okay, I'll put here add. Okay, and for time being I'm closing it. There are a number of others also which okay. Now here self weight, for the first time self weight. Now self weight will be there for the entire structure. Okay, so as such self weight I had already defined it. So if I using self weight, usually that you have to assign to the entire structure as such, all the members here. So I use assign to view. Okay, generally I use assign to view for self weight, and then I click here assign. So they'll ask whether you want to proceed with assign to view. Yes. Okay, so as such this will get changed. Okay, now the question mark has gone here. That means the entire thing has been changed. Now uniform GY. Okay, uniform. I click here, instead of assign to view here I use cursor to assign here. Okay, now I provide it to maybe this corresponding number. So it starts from, if I double click it, you can understand this one. It starts from 1 meter and it will end from the starting till 3 meters. For the time being I'll close the connect version. It's getting a bit distracted. Okay. Okay, now this is a global y direction. Now I'll change this one. You'll understand what is global y, global x. Okay, this is global y negative direction, so that's why -3 here. Now I put here global x direction and I change here. So global, I put global z, then you'll understand. Change here. So this is global z negative direction. If I put here +3 here and I change here, you see global positive z direction is this one. Global x direction is along this beam here. Okay, so when I put global x here and I put change here, you can see the arrows are along this corresponding beam itself. Okay, that is global x direction towards that side. If I put here -3, if I put here change, it will become towards the left. Okay, so that is a different meanings of global x, y and z. So I make it global y here in the downward direction if I want. Okay, and here they will show which members has been assigned that one. So I can put this the same thing into multiple beams, but since I am putting it in the global direction, it will be different. For example, this corresponding thing, if I assign it to this beam, okay, I close here Okay, I assign this one, use cursor to assign, and I assign it to this beam. So it will be different. Why? Because it is in the global y direction here. So here in the global y direction, it will be along this corresponding beam here. Okay, along the beam here. So as such, it will be like this. Okay, understood? If I change this, if I want to assign some load like this, okay, then I'll have to define a new one. Okay, so I click here save button. So save. So I click here dead load, and I click here add, and I click here another maybe member load here. I click here maybe 3 kilonewton in the global direction. Okay, and I click here all these 0 0. If I give here, it will be acting throughout. If I give 0 0 0, acting throughout. So I add this, close. So here it is GX. So this one, what I do now, there is an option. If I click edit, okay, you can see where this here on the right hand side to which members it has been assigned here. So I can, if I click here, I just click here. Now if I click this, you see it will show. It will highlight where the corresponding B numbers has been this one. And if I want to remove any one of these, for example, I want to remove this one. So I simply click the tick button here. I remove this one. Okay, and I click here change. Okay, so that load has been removed here. Okay, this now if I click this one and I click change, it will be assigned. If I click this for highlighting, okay, this for only for highlighting. Okay, if there are large number of beams here, so if I want to highlight it, I can use this. This is for actual assigning, just editing it. So I remove this one. I put change here. Okay, that has gone. I close here. Now I put the last one which I assigned. Okay, and I put here assign, and I click on this corresponding beam here. So you see, since I have put in 0, okay, sorry for the disturbance. So since I had put the value of 0, you see the entire beam as such has been assigned, not from one starting one end to the ending one end like you had here. Okay, the entire beam as such has been assigned from one end to the other beam, the corresponding load of 3 kilonewton per meter. Okay, now next we come to the corresponding next we come to the corresponding nodal load. Okay, so nodal load, I'm using the cursor to assign here. I click the assign button here again, and here, since this is a nodal load, I should click on the nodes here. Okay, so here Fy 3 kilonewton per meter. Okay, in the positive y direction, it is upwards. Okay, so if I want to make it downwards, I can either click the edit button here, or there is another option is by double clicking this one. Okay, any of these options, if I want to edit it, okay, whether it is a grade, property, or what you call it, support conditions, if I want to edit it as such, I can double click this one. Okay, the editing button will come out. Sorry, the editing option will come out, and then I can put this as -3 to give it in the downward direction. So if I change this, okay, and I apply close, you can see that it is in the downward direction. Similarly, MZ, okay, this is still in the assigning mode. Okay, this is still in the assigning mode, so I don't need to again go and press this assigning. Okay, so as such, for example, I am keeping here MZ like this. Okay, just it is not. I will click. Hold on. Instead of MZ, I'll put it here. Okay, close. Now MZ as such, even though it is showing it is a point load, it is not actually a point load. It is actually a moment that is rotating here. For example, let me give you another example of a. I will define a dead load here. I will add a dead load. That is a member load, a concentrated uniform, a concentrated moment. Okay, as such, I will put say 3 kilonewton in the global Z direction, the value at say 4 meters for the time being. Okay, so as such, I had defined this one. So I click add here. Okay, now I assigned this corresponding load at this corresponding beam here. So you see here the corresponding this corresponding load here. Earlier it was shown in yellow, that was not properly visible, so that was, the error has happened. Okay, so as such you can see here that there are two loads here, Fy as well as Mz. Now for the time being I'll make this as 0. Okay, I'll change this, close. So you can see here Mz. Okay, since anti-clockwise, since positive values are taken in the anti-clockwise direction, so it is taken in the anti-clockwise direction around the z-axis. Okay, around, you see this is the z-axis. Okay, around the z-axis, you can see this one. Okay, now if I change this, instead of this one I make it My. Okay, I change this one and I close it. Now you see it is around the y-axis, around the y-axis in anti-clockwise direction. Similarly, if I change this into X, okay, change, close, it is around the X-axis. Okay, so as such, the directions as such is all in the global directions. Okay, all the global directions. Nodal forces are always in the global directions, but the member forces I can give in the what you call it, local direction as well as the global direction. Now to help you understand what is actually the difference between the local direction and global direction, I will draw an inclined beam here for time being. I will draw an inclined beam here from time being at this end. Okay. Now I applied this load, the uniform GY, this load again on this corresponding beam. Okay. So assign, I click on this. You see this corresponding load. Okay. As such, the load is acting in the global direction. Okay, the global y direction as such. So what do you mean by global direction and local direction? Global direction is a global axis that is common to the entire structure, and the global direction for this corresponding structure or any structure in STAAD Pro is given by these left 3 coordinates at the left end. Now each member, I'm talking of member, I'm not talking of nodes. Nodes has only global directions, but members as such has got both local direction as well as global direction. Now how a corresponding local and global direction, how do we see it? So for that, what we do, if you go to local axis, you see each member as such has got a local axis. So if I press Shift O, okay, you can see a 3 system of axis here on each of these members. The blue indicates the local x-axis. The local x-axis is defined based upon how the member has been defined. That means if a member starts from node number 1 to node number 3, for example, then the local x-axis is from this point to this point. The local x-axis is shown by the blue line here. Okay, and then the local y-axis as such is perpendicular to this corresponding axis here. Okay, perpendicular to the x-axis is local y-axis, and the axis is perpendicular to both x and y will be the z. So if I want to apply a load in the inclined direction in this corresponding direction, so what I do, for example, I add a new load, okay, member load, and say uniform force, I am providing 3 kN per meter. Now instead of the global y direction, I provide local y direction. Okay, as such, and I click here add. So entire beam as such, all the beam 0, 0, 0 means entire beam gets assigned that. Now close. Now that beam as such, if I assign, okay, I am clicking the assign button, and if I click here, you see here, I think it is in the positive direction. If I want to make it the downwards, so I have to put a negative sign here. So I put a negative sign here and I change it, close it. So you see here, this is the difference between the local direction and global direction. So here I had assigned the load in the local y direction and given negative. So the load has come in this direction, perpendicular to that. So this is local x. Each member has got its own local x, local y, local z. You see the local x axis of this is different from this corresponding axis. Okay, in this it is inclined here, but here it is inclined from this point to this point. It is shown by here. So local x, local y, and local z. Okay, so there is a difference between a local axis and a global axis. Global axis is based upon this corresponding coordinate which is shown here, and is common to entire structure as such. But for beams as such, depending upon what is the orientation of the beam, okay, depending upon what is the orientation of the beam, either in 2D space or 3D space. Okay, here I have shown 2D space. Whether it is in 2D space or 3D space, each corresponding member has got its own local axis. So you can see that the local axis of this is different, this is different, and this is different. Similarly, local y of all these three are different. Local z of all these three are different. So if I want to see the local axis, press shift plus O, okay, which will help you show the corresponding local axis. Now here one more thing is that you can, on a beam, you can add multiple loads. Okay, here for example, I had added one load in the global direction and the other load in the local direction. Okay, it doesn't matter. You can add multiple type loads on a single beam, depending upon where the maybe how the structure is having different loads. You can have multiple loads. But if you are you have to be very careful of how you are giving the local and global direction properly. Okay, so in some cases it will be shown, most probably it will be visible to you here as such. Okay, so you can identify whether it is local x, local y, and if you have any confusion, please press shift plus O. It will help you identify the local as well as the global axis. Okay, now this is the dead loads. So this, I just gave you a sample, okay, of how the dead loads, how the different loads are there. Okay, and I also told you the moments, okay, moments in the x, y, and z directions. Okay, so as such, whenever a plane structure is given to you, the moment will be in the global direction. Okay, so for example, uniform gx, okay, moments as such, you will be in the 3 km here. Mx, it will not be in the x. Usually if it is a planar structure, it will be in the z direction. Okay, so this I have changed. Okay, so this becomes in the z direction, and I don't think there is any other moment. Okay, there is no moment. So as such, these are the corresponding things. Similarly, now for the time being, I'll delete all these. Okay, just for you to help you understand. I'm not so you can define dead loads as well as live loads. For example, if you're designing a building, so a dead load includes the self weight. Okay, it includes all the masonry walls. Okay, all the masonry walls. As such, these all walls structures will come on the corresponding beam. So as such, you see, as such, we have to properly understand what do you mean by dead load and what do you mean by live load. Okay, because the combinations, these combinations as per code is defined based upon this. If you give this as dead, if I double click this, you can see this is given as dead. So the combination is based upon this, not on this. You can give this one any name. Okay, this title can be given any name. How you have defined in this, depending upon that, this combinations has been given. Okay, similarly, how you have been defined, not the name, but how you have defined which type of force you have defined this one. Depending upon that, the corresponding combinations have been generated. Okay, not depending upon this DL name and LL name. It is depending upon the type of loading you had mentioned here. Okay. Now that is one aspect. So similarly, live loads, I have clicked the plus sign, so everything will be shown. All these question mark indicates that this has not been assigned. Okay, for the time being, I'll assign something. Okay, I click assigning. This actually, so here you see this corresponding thing indicates that a continuous moment is there throughout this beam. Moment is continuously there throughout. Okay, the uniform moment. Okay, uniform moment throughout the beam from one end to other end. So I'll not make this as Y, I'll make it as Z. Okay, change, close. Okay, uniform moment throughout the beam from one end to the other end. Now concentrated GX. Okay, this is actually a force, a concentrated force. So I assign it for the time being in the X direction. For example, I assign it here. So I concentrated force in the X direction. Okay, if I change this into Y direction, okay, change, a concentrated force along the Y direction. Okay, if I change into Z direction, change, close, a concentrated force in the Z direction. So as such, you have to see properly how the corresponding local axis and global axis are there. Okay, and whenever you select a corresponding load, that corresponding load will be shown in blue. The rest of the things will be shown either in green or yellow. If you have multiple loads within this one, you see now I click this one, so this is shown in blue. Now when I click this one, this is shown in green, because it is not the selected one, it's a different one. So for example, for the time being, I'll select this as this is a concentrated moment within a beam. Okay, concentrated moment within a beam. Okay, there. So as such, I will assign it to maybe at this corresponding end. Okay, so a concentrated moment. I think the value is very high, so for the time being, I'll make it a small value, say 0.4, 0.2 for the change. So it is acting at a distance of 1 meter from this end. From 1 meter from this starting node. There is a difference. I told you there is a difference between how you define beams. If you define a beam from this node to this node, then 1 meter from this starting end. If you define a beam from this node to this node, and it will be different. For example, for the time being, I'll delete this. Okay, and then I'll create a beam from this node to this node. Okay, and then I go into general, the loads and definitions. I take the plus sign, and this load now I assign to this. You see, now it has come from this end. So depending upon how you define from this end to this end or this end to this end, the value will change. The word is applied. So it is very important. See, the local axis has also been changed. Okay, the local axis earlier was, x-axis was earlier upwards. Now the x-axis is downwards, because the beam starts from this point to this point. So local x, local y, and local z. Here blue indicates x, red indicates y, green indicates z, the local axis. Then you have the linearly varying load. So I'll just click assigning and I click here. So as such, you can see a linearly varying load in the, I think it is in the local y direction. The linearly varying loads will occur only in the local y direction as such. Option is there for that. Okay. Now similarly, if I apply a linearly varying load here, okay, you can see it is not linearly varying, a triangular load. It is a linearly varying load. You may not feel it. I'll just change the values. I'll make it 1, 2, and 1, 5. So you will feel the difference. Yes, now you can feel the difference. Okay. So as such, these things are important. Okay. Now then you have the load combination 1.5 dead load plus 1.5 dead load, and then two combinations, the service load combinations only we have taken from that hot load combination, rest we have avoided. Okay. So dead load, live load. Dead load for the time being, I'll just assign something. If I don't assign it, it'll give you a warning. I'll show you the warning, then you'll understand it. Okay. So that is regarding loads and definitions. Then finally you have materials. Okay. You can define materials. Now you see this member has already been assigned steel. Why? Because in the earlier property, you see this has been selected as steel. Now this is concrete, so rest of the members have concrete. So if you come to material and if you click concrete, you see these two members have already been assigned concrete. So what I would recommend is that when you select property, okay, don't define this. Okay, don't define the material. When you come here in the material part, you define it. That would be better. Okay, now for the time being, I'll take all as steel. Okay, so if I want to assign to view, I can assign to view as steel. Or for the time being, I'll assign this steel and rest of the members in concrete. Okay, so concrete, assign to selected beams. I click assign. They ask assign. Yes. Oh, so assign to selected beams. I use cursor to assign. Okay, assign. You see that this is a cursor which changes for material property. So I assign this. And now I click steel. Now I click concrete. Okay, steel, concrete. Similarly, the other options for assignment is also available. Now, besides this, you can also define or create a new material. Okay, you can define a new material. Okay, for example, if you are defining, say, another material, then you have to give the corresponding property: Young's modulus, Poisson's ratio, density, thermal coefficient, critical damping, shear modulus, etc., etc. Okay, whatever you want to provide. Now, if you want to retain any, for example, if you want to get RCC, this one. So what I do, as such, I select here concrete. Okay, then I know that the density, rest of the properties are almost same. Okay, density is slightly different. So as such, if any of these properties are slightly different, then I select the closest one. Okay, I select, for example, I want to define RCC. Okay, so I select the closest one, concrete, and I change the name to RCC. So all these values will be you can edit it. Once you change this one, you can edit it. For example, the density of RCC as per Indian code is 25. So I click here 25. I click here OK. So now it has got RCC. So I can use, for example, I'll use assign to edit list. Okay, I'll on the beam numbers, shift B. Okay, I come to materials, RCC, assign to edit list. Okay, 16, 20, 21, 19. Okay, now remember one thing. Okay, we'll discuss it later. So 16 space 19 space 20 space 21 and assign. Yes, so this has been assigned RCC. This one is steel. Okay, so you have studied property, support, loads and definitions, material. Okay, in the loads and definitions there is something called load envelope, which we'll discuss later. Specifications also we'll discuss later. Then comes the analysis bar print. So this is the analysis command in which we have to specify what type of analysis we are performing. Okay, for simple elastic analysis, the first one, perform analysis, no print is sufficient. Okay, it depends upon what things you want to print. Okay, so no print is sufficient. If you just want to view it, you can click no print, and then this corresponding thing will change. So it become change. Okay, and then all the corresponding things you have given here will be shown here, and then finally if you click add, at the bottom you'll see a perform analysis. Okay, if you don't give perform analysis, okay, it will not analyze properly. After giving the perform analysis, okay, then only you can analyze it. Okay, now you see this is the corresponding things we had done so far. Okay, now remember one thing, STAAD does not has any relation to the corresponding what you had done here. Okay, STAAD reads only the corresponding commands that is available in this code. Okay, for example, that code you can view it by going to something called the STAAD editor. Okay, you see this STAAD editor, this corresponding toolbar. Or if you go to geometry, if you go to edit, you can see the edit input command file. Okay, edit input command file, or in the tool, in this toolbox here, you can see this corresponding STAAD editor. Okay, so it will ask structure has been modified. It's just asking, just saving it. Okay, just saving it. So a window will open which will show you all the corresponding commands, means all the corresponding steps you had done so far. Deleted ones will be over. You see, STAAD looks only at this corresponding file. Remember one thing, if you have this code, you can replicate this data. If you have this code here, you can replicate this data. Now I'll just explain the basics of this corresponding STAAD editor because it is very powerful. STAAD editor is the most powerful thing that can means that is available there among other softwares. Okay, among other softwares they don't have this editor powerful. Means this very powerful thing. Any change you make here will be reflected in this. Now for example, I'll show you how it is. Now first one, STAAD plane. So we had first selected, while starting we had selected a plane. Means there are 4 types. plain, truss, space and floor. So we had selected plain and hence the plain comes. The second was edit job information. Okay, so in the edit job information we had provided only one data, engineer's date. Rest everything was not provided. Okay, for the time I'll close this one. I'll go to setup, the first one, job information. Only value which was provided to me was this one. Now for example, if I'm providing here the engineer's name, for example I provide my name. Okay, some job information 234, this one something, this one something. Okay, whatever is, I have given a few things, I had avoided a few things. Okay, now if I go to STAAD editor, it will also save button every time when it opens STAAD editor. Now when I see the STAAD editor, you can see that the values which has been given here, that will be there in the input code editor. STAAD editor will take some time to load. You can see here. Now start job information and end job information. In between this, what you had provided here. Okay, I'll just move it here close here, you can understand it. Okay, what you had provided here, that things will be shown here. So this is the starting of the command, start job information, and this is the end job information. Now if you provide some comments, that will also come between this start and end. The next is the command is input width 79. Input width 79 is a corresponding input the system which you have chosen. Okay, depending upon that. The next line is units. We had selected meter and kilonewton in this beginning. So depending upon that, it has come here. The next is the different joint coordinates. We had there are number of joints here. Okay. Okay, there are number of joints here. So joint coordinates 1 0 0 0. That means joint number 1 has coordinates 0 0 0. Joint number 2 has coordinates 4 0 0. So not joint, node. Node number 3 has coordinates 4 5 0. Node number 4 has coordinates 9 5 0. Node number 5 has coordinates 9 0 0. So you can see that 1 2 3 4 5. 5 nodes. 1 2 3 4 5. 5 nodes and their corresponding numbering as well as their coordinates is what is given here in this line. The next is member incidences. Member incidences refers to the members. So member 16 connects node number 1 and 2. So you can see number 16 connects node number 1 and 2. Member 18 connects node number 3 and 4. So 3 and it starts from here. As I told you, we had changed it. So it starts from 3 and ends in this one 18. It starts from 3 and ends in 4. Then 19, 4 and 5. 19 starts from 4, ends in 5. 20, 1 and 3. 20 starts from 1 and ends in 3. 21 starts from 3, ends in 2. 21 starts from 3 and ends in 2. So these are the corresponding things. Next is the member properties which were assigned here. Okay, I'll come to this side. I'll select here general property. So property, first the rectangular we have chosen 0.4 into 0.25. So here the member property, there is no material as such here. Member property 16 19. That means the members 16 19 have been assigned a prismatic member, that is a rectangular member whose YD is 0.4 and whose YD in the sense YD is the depth and ZD is 0.25. Okay. Next member property Indian means this is we had defined this. This is actually from the section database. So that member property as well as from which code we had taken. Then that is 18. 18 indicates to the which member we had assigned that member property. You can see here we had assigned 18, this corresponding as steel section. So that has been given here. So 18 table ST. Table ST means it is from the section database and ISMC 125H. Okay, we have taken ISMC from 125H. Then next starts the define material. Okay, define material. So here in this case after property actually material comes. Okay, after property material comes here. So the material as such, you see we had defined As such, concrete was there. We had, I think, I don't know whether I given concrete or not. No, I have not given concrete, but still concrete has come here because during the first step I had assigned a few members concrete, and then I had changed it. So as such, the concrete is defined of all the properties. Okay, if I click this concrete here, sorry, if I click this concrete here, I'll change this here. All the corresponding properties of concrete which we have defined will come here. Then steel. Okay, the corresponding thing we had defined for steel. Since we had already assigned steel, okay, I think one member is steel, so that thing has come. Okay, and then finally RCC. Okay, and even though there is no concrete as such in this corresponding, because now we can see that in this figure there is only RCC, but in the first beginning we had given one concrete, okay, and then we had deleted it, but somehow the STAAD editor did not change it, so as such it will not make any error as such, let it remain there, it does not have any effect. Now once all the material properties have been defined, next is the term constants. Constants will refer to the thing that which corresponding members has been assigned which material. So material concrete is assigned to member 20, material steel is assigned to member 18, and material RCC assigned to member 16, 19 to 21. Now when I say 19 to 21 means 19, 20 and 21. Okay, whenever the word 2 comes in STAAD editor, it means between those two. Okay, so it means 16 is there, then 19 is there, then 20 is there, then 21 is there. But here it is given that member 20 is concrete. Let me see whether it is concrete or not. It is given here steel. So some problem is there with this. Okay, it has given here as it has become twice. You see, twice it has come here. 16, 19, 20 and 21 also, and here again it has come here twice. So for the time being I'll delete this one. Okay, I deleted that one because by deleting it okay. Now then supports. So after property, as per the STAAD editor, after property comes material, and then even the constants as such, if there is specifications, that will also be mentioned. For the time being I'm not defined specifications, so I had avoided that. Next comes supports. So supports node number 1. These are see, it depends upon, you see, whenever I say supports are assigned only to nodes. Okay, so as such this one is not beam number but support number or node number. So node number 1 is assigned fixed, node number 5 is assigned pinned, node number 2 is assigned fixed, but then we had released fx and mz. Okay, if you go to support here, okay, node 2 here, you see 1. Okay, so 1 is fixed, this 5 is pinned, this 2 is fixed but with fx and mz released. If you double click this, see fx and mz has been released. Now if you give some value here in the stiffness, those values will also come here. For example, if I give here for the time being kmy, I'm for example providing 23, I click change. Okay, I close this one. Yes, hold on. Support 4, I edit it again. While the STAAD editor is working, if you make any changes, it will not come to STAAD editor. Okay, once you close STAAD editor and then you make the changes, then only it will be reflected. So I change this. Okay, now if I take the STAAD editor, if I come down, you see here, okay, 2 fixed but fx and mz has been released, but stiffness kmy, stiffness along the moment y direction has been given as 34. Now here the units will not be given to you. Units, since we have already assigned the units in the first, okay, it means that the units has already been assigned. You can see that in any of these as such units will not be given. Okay, since units has been already assigned earlier, it knows that what will be the units for each of these. Okay, depending upon the metric system. Okay, so what I would like to remember say is that supports are assigned to nodes. Okay, and material properties as such are assigned to beams. So it will identify material properties as well as the member properties are assigned to beams. Okay, so it will know that which is beam and which is node. STAAD will understand. Okay, so don't get confused. Okay, one may there may be a node number with numbering 1, and there may be a beam number with numbering 1. Both will be there. Okay, so don't get confused. Next is the load type, load definitions. Since we have not defined any loads, definitions are not there, so that has not come into picture. We have defined load cases, in which you see that load case 1, load type 1, load number 1. That means the numbering of this is 1, and the load type is dead load. If you click it twice, I told you the load type is dead, and the title what we had given is DL. Okay, so depending upon that corresponding thing has been given to you. Okay, load type 2, and in load type DL dead load we had not given any load, so as such there is nothing under this. Now in live load we had defined a number of loads, so that has come into picture. And then there is a load combination. Okay, load combination, there is no need of defining. It will already take the values from these two. Okay, it will already take the values from these two. Similarly, these two also, they will already by default take the values from dead load and live load. So you see load combination. Okay, 3, 1.5 dead load plus 1. This is just a title. Okay, this is just a title. It doesn't have any meaning, but this corresponding thing has a meaning. This means that the first load case, that is dead load, multiplied by 1.5. The second load case 2 multiplied by 1.3. Okay, now load combination 4, that is generated by the Indian code general structures. So 1, 1.2, 2, 1.2. That means dead load 1.2 times plus the second load case 1.2 times. Now the third one 1.9. That means the dead load will be taken 0.9 times. Then finally the perform analysis command and the finish command. So as such, this code is sufficient for you to generate the entire structure as such with all the properties. I'll show you how it is, and before that let me first close this. When you close this one, it will ask to save it. Okay, it will ask. Now dead load for the time being, I'll assign one dead load here. Okay, I'll add self weight for the time being, otherwise it will be okay. And this question mark to, now we'll keep this question mark as it is, okay, to see what error will come. Okay, and then after analysis and print we have finished this one. Okay, and then design is there. Here we are not going to design part, we are only going for analysis part. Okay, so there's no need of clicking the design button. Design button will give you a number of other things depending upon what you want to design. I'm not going to that part. I'm closing with analysis bar print. Okay, after you select this part, perform analysis, you go to this command analyze and click run analysis. So when the run analysis command is given, it will ask you to save it. So I had saved the file, and then it will perform the analysis. Okay, perform the analysis. As such, you can see the analysis being performed, and see processing join coordinates, processing member information, reading member properties, something here. But you can see that some errors has there, some errors, 2 errors and 0 warnings. Okay, so when there is an error, there are 3 options here. View output file, in which you can see the output file, and then there is a go to post processing mode. Go to post processing mode will work only if there is no errors as such. And then stay in modeling mode. This corresponding mode is called modeling mode, the first mode here. Okay, this is the modeling mode here. This is corresponding modeling mode. So some errors are there. So if I want to see the errors, I have to click view output file and then click done. So as such, another window box will open and it will show you the corresponding errors and warnings. So as such, you can see here error. Okay, here error as such. If you go, this the entire you can see the entire STAAD editor file has first been provided. Okay, the entire STAAD editor file. Okay, after that, when the analysis has started, you see that section properties are not entered for member 20. That means section properties means the the area as such properties are not being defined. So as such, this is the error. So we'll see what has happened. So if you go to section properties, means you have to go to general and then property. So you see, this has been given, this has been given. Okay, if I select this, this has been given. These two has not been assigned anything. Okay, so that is why member 20 and 21 has not been assigned any section properties. For the time being, I'll take these two also to be this one. So what I do, I'll select both of these. Okay, and then I'll assign to selected beams. I'll ensure that this is here itself. First, you remember every time, first you have to select here. Okay, and then you select these beams. Okay, or you can also use control. You can select one beam, then control and the other beam. Now you see here, if I move my corresponding beam if I move my cursor close to a beam here, you see a red line is shown. To the left line, there is a green line shown, and to the other end, there is a blue line shown. The green line indicates that that is a starting point. Okay, that's a starting point, and the blue line indicates the ending line. And also a tool tip will be shown here, showing which beam number it is. If you select the node cursor and you bring it close to the one node, you can see that a tooltip is opening, giving you number 3. That means that is node number 3. Okay, similarly, the same thing will happen also to plates. So I'm not going to that part for the time being. My intention is to assign the beams here. So what I do, I select the beam cursor, I click here, I select these two, I use control. I can select this one and then use control and then select this one. Okay, you can use also to control select multiple options. Okay, and then I click assign. Earlier it was 16 and 19. When I click, whenever you click any of these, by default it will come at the bottom here. So here earlier only 16 and 19 were there. Now if I click here assign as such, even though I had used assign to selected beams as such, when I click yes here, 16, 19 to 21. That means 16 is there, 19 is there, 20 is there, 21 is there. All these 4 members as such will be assigned the corresponding material sectional property rectangle 0.4, 0.25. Okay. Now I go to again and analyze. I already defined the thing, so I just need to go to run analysis once again, and I click save. Now you see it has been processed. 0 error but 1 warning. Okay, warnings as such indicate that there may be a problem. If the structure is not modeled properly, it indicates that some issue is there. So even though warning is there, you can go to post-processing mode. Okay, even though warning has been given, you can go to post-processing mode. But a very expert structural engineer, he will look into the warning also, because warning can be serious. Okay, warning can be serious, which can give you wrong results. So instead of going to the, I can either stay in this modeling mode, I can view the output file, or I can go to the post-processing mode. Okay, I told you earlier that there is a pre-processing, okay, and then there is a post-processing. So you can go to the post-processing mode to view the results. But since I want to see what that warning is, so I go to the view output file and I click here done. So again that window will get open, and then you can see some here warning: out of plane loads applied to a plane structure. Means one of the, we had defined the corresponding structure to be plane, STAAD plane here, but one of the loads when you had given them, you had defined out of the plane. So if I want, we'll go, I close it, I'll check which has been given out of plane. So I close this, I go to loads and definitions, I click here, dead load self weight is there. For the time being, I'll delete this self weight. Okay, see, even though this question mark is there, it has not it has not been shown, it has not been assigned anything. For the time being, I'll just delete this one. Okay, I have deleted self wait. And the live load, you see, which has been given out of plane. You see here, this concentrated GZ 3.2. This is out of plane. That means this is in the Z direction, along the Z direction. Okay. So this structure as such, we had defined it to be a plane structure, but this loading I had given in the Z direction, along the Z direction of the, here you see X, Y and Z. So for the time being, I delete this. Okay, and then I go to analyze, then I click run analysis. So one warning comes here. One or more empty load cases are detected in the model. That means the dead load is empty. There is nothing inside it. Okay. So they'll ask, do you want to run the analysis with empty load case? So I click here no. So I click here dead load. I add something. For the time being, I'll add self weight. Okay, I'll add here. I'll just bring to the left. I add here, so it comes here on the right hand side. I close here. I click this. I assign to the entire structure, assign to view, because I want to assign to the entire structure. I click assign. They will ask a warning whether you want to assign to view, because assign to view is very dangerous, because we are assigned to the entire structure. We cannot, then changing of assign to view becomes very difficult. Okay, so be careful while giving assign to view. Then I click yes. Then the entire thing has been assigned. Then I go to analyze, and then I run the run analysis. Then I click the save button. So as such, you see now 0 errors, 0 warnings. Okay. Now before I go to the post processing results, I'll have to show you what these things indicate. Okay. So first, processing the join coordinates, means we have defined the join, so what it is processing them. Then member information, then member properties, then finish reading member properties, then reading member properties once again, because there are two member properties here, because one was defined section, one was a sectional database, so it has come twice. Then processing support condition, then checking the data in the load cases, okay, whether there is anything. Then from here starts your FEM, from using out of core basic solver. From here starts the FEM part. Okay, so the processing and setting up of load vector. So it sets the load vector. Then the element stiffness matrix is formed. Okay, and then the global stiffness matrix. And then you process the global stiffness matrix. Process means you are adding the proper matrices to properly. So processing of the global stiffness matrix, and then finish processing global stiffness matrix, and then processing of triangulation factorization. Triangular factorization means you are making the triangulation part of the matrix as such to get the exact results. Okay, you are solving that matrix part. Okay, so that is triangular factorization. And then once you do that, then you calculate the joint displacements. Joint displacement means calculating as well as finishing. Then member forces are calculated. The same steps you see in FEM, the same steps are here. Then finally, they calculating the section forces. The rest of the things are the same as such. Okay, so here again you can either stay in modeling mode, or you can view the output file. The output file is the earlier thing as such. If you go to output file and done, you will see the output file as such. Here nothing is here. Usually when both error and warning is there, warning will come first. Okay, and then error will be at the bottom. Okay, there will be a tab for warning. There will be a tab at the bottom for errors. Okay, in the left hand side. Now there is no errors, there is no warnings. So as such, everything has been done. You can see the corresponding output viewer. Okay, so as such, or you can go to post processing mode directly. So it will show you the results. Or you can stay in this modeling mode itself. This is the modeling mode. So if you have already been processed, if the entire thing is completely processed and if it has been solved, you can go to the post processing mode by clicking on this green post processing here. If you click the post processing here, a corresponding thing will show up. Okay, they will ask for which loads you want to view the results. Okay, for which load, whether only dead load, whether only live load, or whether all these. So I want to analyze for all these. So I click here OK. I can take any of these to the left hand side. Okay, I can take any of these to the left hand side. If I don't want these two, I can remove it. Okay, if I think later that I don't want them, I can remove it, or I can include all them. By default, everything will be selected. What we had defined here, everything will be selected here. Okay, by default. Or if you don't want any of these, you can remove it. Okay, for example, if I don't want the basic load cases, if I don't want the results of the basic load cases, I only want the combinations, I can give like this. Okay, it doesn't matter. And I click here, OK, and then the corresponding thing will changes into the post-processing mode output. Okay, when I click the post-processing mode, you can see here the corresponding pages also gets changed. Earlier it was setup, geometry, general, etc. Now it has been changed to some other conditions as such. Okay, other pages and sub pages. Okay, now you see this corresponding results can be shown here. Okay, the corresponding results as such is shown in tables on the right hand side. The first, when I click the node here, okay, the first is the node page, the first sub page is displacement. So when I click the displacement, okay, in the top table here, for each load case, there are 3 load cases which we are which are analyzing. 3, 1.5 times 0 for or each of these load cases. What is the corresponding displacement along the x direction, y direction, z direction? So here, therefore, node number 1, node number 2, node number 3, node number 4, etc. Node number 5. Okay, node number 1, as such, x, y, z, there is no displacement. Why? Because it is a fixed. Similarly, x, hold on, x, y, z, then the resultant of x, y, z, and then finally the rotation along rx means in the 3 directions, rx, ry, rz. For each of these load cases, for each of these nodes. And then you can get also a summary of this. The minimum value of displacement along y, the maximum value of displacement along z, whatever the resultant also you can get here. This is sufficient. I would prefer this one. And then the next is the reactions. Okay. The table below this one actually indicates the beam displacements, but this we will discuss later. Next comes the reactions. Reactions will show you at where we had assigned the supports, what is the reaction there. What is the reaction there. So that also you can see here for each of the nodes where there is a support, only where there is a support, it will show the reactions for each of the load case. So fx, fy, fz as well as mx, my, mz. Here you see, since this is a planar figure, okay, you can see that mx and my are 0 everywhere. Only mz will be there, if there is any. Mx and my will be 0 everywhere, since this is a planar figure. Or planar is a structure in a plane. So as such, you can see here. Okay, and then you can get a summary of this minimum value of fx, minimum value of y, and then you can also get an envelope. We will discuss envelope later. Okay, now beam. So earlier, when I click node here, you can see a table here. This is actually the beam displacements. The same thing is available when I click the beam here. The same table is available here at the bottom. Okay. So in beam displacement, you can see that for each beam, 16, 18, 19, for each beam, for each of the load cases, what is the corresponding reactions? Now, reactions at the 2 end nodes. Now here beam reactions as such are expressed in local coordinates. You can see the difference here. You see here when I click the nodal reactions, the nodal reactions as such fx, fy, fz, mx, my, mz are given in the global directions. Okay, in the global directions. But beam reactions, the forces fx, fy, fz are actually in the local directions. Okay. Here fx indicates the axial force. Fy indicates the shear force in the y direction. Fz indicates the shear force in the z direction. Here, since this is a planar figure, there is no shear in the z direction. Okay, we are not applied any loads in the z direction since there is no shear in the z direction. Now mx indicates the moment, bending moment along the x direction. bending moment along the y direction, and mz bending moment along the z direction. Since this is a planar figure, we have only mz bending moment along the z direction. Okay, so fx, fy, fz. Remember one thing once again, here for a beams, fx, fy, fz, mx, my, mz are in the local directions. That means they represent, fx represents the axial force, fy represents the shear force in y direction, fz represents the shear force in z direction. Similarly, mx, my, mz, the bending moments along the three directions. Okay, so for example, what is the axial force along this corresponding x? What is the shear force along this y? What is the shear force along z? Okay, and bending moment. Okay, there are three bending moments here. Okay, for time being we'll avoid mx. Okay, mx it does not have any meaning here, but mx in this case will refer to the torsion. Okay, when this corresponding mx as such will refers to the short torsion for this corresponding member. Mx refers to torsion, my refers to the bending moment along the y direction, mz refers to the bending moment along the z direction. Means there will be a bending moment along like this as well as along the other direction, along the y direction as such and along the z direction as such. And mx refers to the corresponding torsion, how much it has rotated. Moment in three directions. That is the meaning of that. Okay. So that is very important to understand what each of these means. Okay. Similarly, a table is given here at the bottom. In the bottom table, here only at nodes are given. Here, not only at different distances within a member. So a member as such it may be divided into maybe 4 or 5 pieces, and each of these pieces, okay, at each of these sections, what is the value of fx, fy, fz, mx, my, mz? The above one is only at nodes here, at one end and the other end. So you get one value here and one value at the here. But the bottom here at each different section within a member, okay, what is the value of the sectional bending moment, axial force, etc., etc. Okay, so you can here, and their results can be shown here. So if you want only maximum axial forces, maximum bending moments, maximum shear forces. Okay, maximum shear force both in fy and fz direction. At what distance it is maximum shear is there. Okay, every results will be displayed here. Similarly, you can get the stresses. When I click the stresses, okay, the corresponding stresses, what is the value of stress at each of the 4 corners. Okay, this in a three, they are showing the corresponding value in colored contours, but here in the table you can see here at different corners. Corner 1, 2, 3, 4. This rectangular portion has got 4 corners. At 4 of these corners, what is the different stresses? Okay, so you can see here at the top the stresses are negative, at the bottom the stresses are positive. As such, depending upon how the stresses, because it's a bending as such, so the stresses will be at the top and bottom will be different. Okay, so that will also be shown here. Okay, so these are corners at each different points here, at each different sections. As such, a beam may be divided into maybe 4 sections. Usually 4 or 5 sections a beam may be divided into. So at each of these 4 sections, what are the stresses? Okay, that will also be shown here. Okay, now one thing which I would like to stress is that if I go to node here, this corresponding thing is actually a visual display. Okay, if you want to this is actually showing the displacement. You can see here at the top here fx, fy, fz, mx, my, mz. This refers to the all. Fx you can see axial force, fy shear y force, shear z force, mx torsion, my bending moment, mz this one, and then you can see deflection. Now deflection is on, but you cannot see the deflection properly because it is very small. So if I want to scale it, you simply keep pressing Ctrl and roll the mouse. Press Ctrl and roll the mouse in. Okay, if you roll the mouse in, it will show the reflection in a much more large scale. Okay, if you roll the mouse out, it will show the reflection in a less scale. Since the reflection is very small, we will not be able to see it properly. Similarly, you can hold on. Fx, if I remove the displacement, I can remove the displacement, I can see the axial force. I remove axial force, I can see the shear force in y direction. Shear force in z direction is very small. I can see the torsional value which is also very small. the moment in y direction will not be there because it's almost 0. MZ, you can see, you can slightly see, if you put control and if you roll the mouse, you can get a better scale of that. Okay, so that values will be displayed here. If I want to show the values in this one, I can go to results, okay, view value, and if I want the node results or beam results, if I want beam results, I want to find the bending moment. Now it is in, now remember one thing, whenever this is on, depending upon that we can click here. That means here the MZ is on, so I want bending moment, I want say maximum, midpoint and end point, and when I click annotate, the values will also be shown here. Now I remove this one, annotate. Now I click shear, I click annotate, it will not show. Why? Because the shear is not on here. I should on the shear Y force here. Okay, so I click here and I click MZ off. Now I can show all these, okay, in one single figure, too complicated. I always put one, okay, don't put all on all of these. Always put one on and the rest off. So here now I can see MX, MY, MZ. Okay, the problem with the view, there is one problem with STAAD Pro is that the results will not be shown properly. You see, one above the other it is showing and we cannot read it properly. This is the drawback of STAAD Pro. The results can be better read from the tables rather than by looking at this. Okay, similarly if I remove this one and if I click this one and click annotate, it will show this one. Why? Because I had not on the axial force. So I click the axial force and I will remove the Fy, and then now hence I can show the result value. Similarly now displacement, annotate, it will show this one. Why? Because the displacement is not on. So I on the deflection and I remove this one. I will show the reflection. This is just for a visual representation as such. Okay, don't take this into much effect. And remember one thing, this corresponding visual representation is shown only for one load case, the load case that is mentioned here. Okay, means now if I change this one, this will get changed. If I change this one, this will get changed. So remember one thing, the result analysis are based upon the different load cases for which you had defined. Okay, for which you had defined here, and that results here are shown based upon which you select here. For example, if I select 1.5 dead load, it's something different. And for example, if I change the axial force, displacement I avoid it, and I'm putting the axial force, annotate, displacement I off it, annotate. So displacements are shown. Now if I change this, the value gets changed. If I change this, the value gets changed. So for each of these different load cases, that is what is shown here. Okay, so don't refer to this one. I would recommend you to refer to the tables. Okay, okay. So results, if you go to results, view value, okay, you can annotate the other beam. And now if on node results, you can put node also. Okay, for example, I remove fx also. Now we can, if you want node results global x, so in order to annotate the node results, you must on the displacement. So I on the displacement. Displacement I on it. Okay, annotate. So it will show the x. Annotate x and y. If I remove y and z, and then resultant, if I click annotate, it will show the corresponding resultant value for z. Annotate. And that too, depending upon which you are selecting, it will change. There will not be anything in z because z is 0. There will not be displacement along, since it is a planar figure, there will not be displacement in z direction. So y, if I choose annotate, and if I change this one, depending upon what you had chosen, the value will get changed here. Okay, the value will get changed here. So this is just for a visual display. Don't refer to this much, refer to the tables. Tables will give you the entire value for different load cases. For node number 1, for load case 3, 4, 5. What are the different values? Okay, and then I think there are a number of ways in which you can result the report. So this is a brief outlook of what STAAD Pro is. Now before I wind up, there is one thing I would like to tell you. I told you that the STAAD writer as such is the most important tool in the STAAD Pro software. So if I have this Excel file in the net, you see in most of the STAAD Pro things will be shown by the STAAD editor code. Okay, so if I copy this, for example, I copy this file here, like control copy, I copy this file here. Okay, and then I start a new STAAD Pro file. Okay, for typing I start a new one. I simply put something new project. I just put something, so I just name it maybe structure 7 something, and I use something and I click next and I put something finish. Okay, now there is nothing. Hold on. Okay, there is nothing here. Okay, it's a basic outline. Now I go to STAAD editor. Okay, now I replace this from the earlier one I had done here. Okay, I replace the earlier one. Okay, this one is the earlier STAAD editor one. Okay, I replace with the this one, and then I save it, I close it. You see, the entire model gets regenerated. Okay, the entire model gets regenerated. You see, this is structure 6, okay, which we are defined right now. Okay, the entire thing that was here, okay, in this modeling mode, whatever was this has come to this. Okay, maybe the views will not be there, okay, but all the corresponding properties. So if I analyze this new structure which I created by simply copying and pasting the STAAD editor file, okay, by simply copying and pasting the STAAD editor file, I'll get the same results. You see, no warnings, no errors. I can directly go to post processing mode if I want and click done. Okay, the same thing if I want to click OK. The same thing will be displayed here. If I want to see, for example, if I want to see the generated Indian code 4 and I want to see the value of displacement, okay, for the first node. Okay, now you see, if I come back to the other one, I go to post processing mode. Okay, I go to the generated 4th one. I think this is 4th one itself. Okay, 4th one. Okay, and here you can see here for node number 1, or I'll look to some node number 2 for 1.5 DL plus 1.3, it is minus 0.003. If you go to the other STAAD window, okay, for node number, hold on, this is for 3, okay, and node, this is node displacements. Okay, similarly node displacements, you can see that here the thing is that I had shown all the 3 things. Okay, earlier I had shown only for 3, 4 and 5, but here I had shown here also 1, 2 also. So 1, 2, 3, 4, 5 all has been indicated. So compare any value, for example node 2. Okay, node 2 for load case 3, it is minus 0.003. So if you come here, node 2 load 3 1.5, it is actually minus 0.003. So same results, just by copying the STAAD editor file, I'll get the same model, ditto copy. Okay, so in the net, usually what they give you the STAAD file is actually the STAAD editor file. Okay, so once you are able to copy the STAAD editor file into your editor, the STAAD means a text file. You can be given, maybe you should be given as a text editor file. So if you copy it, you can get the entire model. Maybe some errors may happen due to the differences in the versions of STAAD Pro. Okay, some errors may happen due to the difference in versions. Otherwise, it is the same model. So with this, we wind up this session. It's almost 3 hours. This session was actually meant for those who could not participate in the in the offline classes. So even those who are online can maybe look through it, because I had tried to cover almost most of the portions of the STAAD Pro. From the next session class onwards, I will discuss each of these exercises, but I'll be discussing those things in very brief, because now you already know how to, you have seen the software. Okay, and I hope you must have all got the software. The software is with you, available with you. So as such, in the next session onwards, I'll discuss, maybe tomorrow itself, I will complete all the exercises maybe in one single go. Okay, all the exercises. I think I have I wanted minimum of 10 exercises are there, which we want to be completed in the STAAD Pro. All the 10 exercises maybe in one or two goes. Maybe in one session or two sessions we'll complete the entire session or entire course itself. Okay, fine. Thank you all. Thank you for your patience.